Have you ever wondered how cryptocurrencies actually work? Not the price charts, not the hype, not the get rich quick stories, but the real technology behind it all. See, cryptocurrency isn't just digital money, it's programmable money. Money that follows rules written in code. Money that executes automatically. Money that no single person controls. These rules, they are called smart contracts, and they power everything in crypto. Every DeFi protocol you've heard of, every NFT marketplace, every decentralized exchange. Billions of dollars are controlled by this smart contract. And today, you're not just going to learn about smart contract, you're going to build one from scratch. Welcome to SecretPay tutorial, and I'm so excited that you're here. Now, before we start, I want to address something important. Maybe you've never written code before, or maybe you don't even know what the blockchain is. Maybe you clicked on this video thinking, I have no idea what I'm doing here. That is absolutely perfect, and that is where I want you to be. By the end of this tutorial, you're going to build a password-protected cryptocurrency transfer system, and we are going to deploy it to a real blockchain, and you're going to understand exactly how it works. This is what makes this tutorial different. I'm not assuming you know anything. Not what the variable is, not what the function does, absolutely nothing. Every single concept will be explained from scratch. In this particular section, you'll be learning what smart contracts actually are, how to use the free online tool to write them, and the basic building blocks of Solidity, the language that we'll be using. And also, you're going to write your first Hello World program. And by the end of this particular section, you would have written and deployed your first smart contract on a real blockchain that you can show to anyone. If that sounds good, let's start at the very beginning. Now, to get started, let's head to Remix. Let's search for Remix IDE. Remix IDE. So Remix is an open source Web3 IDE platform to build, test, and deploy smart contracts in your browser. So let's check whether so Remix IDE is loading. We do not have to install anything on our local machine. We can just proceed to use Remix IDE right in our browser. Now, this is how Remix is going to look like as at the time of recording this tutorial on your end. But if it's on a later time, it's okay if it is different, if it's a little bit different. Now, Remix comes with quite a number of functionality. We have some tabs on the left-hand side. It now has an AI assistant. This is the file explorer section, the search in files if you want to search for your file, right? This is the Solidity compiler, the deploy and run transactions, and quite a number of things. We're going to see all of this in details as we proceed. Now, what we'll be paying attention at the moment to will be the file explorer section, and quite by default, it comes with a number of directories like the depths, the state, artifacts, contracts, prettier, readme.txt, and all of that. So the prettier is like the structure of how the file should look, how formatted it should be. The contract is where the contracts will be stored. The artifacts is like where compiled and builds will be stored. The state for VMs, virtual machines, and these are for dependencies, right? So in getting started, we can delete this. We can delete all of this. We can also delete the states folder, the artifacts folder. We do not need any of this. In fact, we can delete the grid doors. So I think I've tampered with the contract. Your contract might come with 3 files, like the ballot, storage, and all of that, but I've tampered with my own contract file. So we can also delete the state and just leave the contract at the moment. Now, with this functionality, with Remix, we can do quite a number of things. We can actually write codes, right? We can also deploy, we can test, and it gives us quite a number of functionalities to access. Now, you're looking at the Remix ID, and an ID stands for an integrated development environment. And it's a fancy talk for a place to write code. So let me give you a better tour or a better approach of how we can use it. So this is the Remix assistant. You can actually use it to maybe for queries and all of that. Let's ask, how do I fine tune my Solidity code? So the best state. If we ask, it's currently in a beta mode. Enter. It says to fine tune your Solidity code for security, gas efficiency, blah 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 blah. It says quite a number of things, but at the moment we can just we want to keep it hidden. Right, we want to keep it hidden. We would not be using it at the moment, but it can be of help to solving errors or when you come across bugs in your code. So the contract folder, I can just take this all away and also take all of this away. So for this contract, this is where we're going to be storing contracts that we would be writing, and it's very, very important as we proceed. So on the left hand side, you can see the file explorer. This is where our code files would live, like the contract and all of that stuff. Then we also have the search, where we can actually find text in our files. We wouldn't need this much as a beginner. Then we also have the Solidity compiler, and this is very, very important. Now, the Solidity compiler helps us to turn our code into something the blockchain understands. Think of it like translating English to Spanish. So you're going to be clicking on this before testing. So you click here before testing the Solidity compiler. Then we also have the deploy and run. This is very important. This is where you test your contracts, like pressing play in a video game. So we'll be spending a lot of time here, right? Now let's go back to this. Is on this side is our editor, this center area. So this is where we're going to type our code and all of that stuff. Then the bottom, it also comes with a bottom area called, this is the terminal, right? So it's like where we get to have conversations with the computer. So when you see the green, it means like we're doing everything well. And there's sometimes whereby you would see like a error note, like a red, which shows that we have some bugs that we have to fix. So that is a quick introduction to Remix. So Remix is a Web3 integrated development environment where we can write, test, and build Solidity codes or our code bases without doing anything in Visual Studio Code, like a custom IDE that we have to download on our local machine. So let's create our first test files. Now, once you're over on contract, you're going to see this is to create a new folder. This is to create a new file. This is to rename and to delete. Right. So because we want to create our first file and we want to create our first Hello World project, right? So we can just click on create new file and type hello world.sol. So this is going to be the name of our file, and .sol is the syntax used for Solidity files. So we're just going to hit enter. So with this, we've declared that we're creating a contract called hello world.sol, and it has to be in the contract folder. So once we're done with this, in the center area where we have our code, where we get to write our code, we can do quite a number of things. Now, the first line, when you want to actually build anything in Solidity, right, we have to declare a syntax. And I'm going to explain what this is. Now, we have to declare the license identifier that we'll be using in our code, right? So we do it like saying // and we call it spds license identifier, then we can say MIT. And you might be asking that what does this mean? Now, firstly, whenever we start in our code base, whenever we start with the 2/, it signifies a comment. Now, comments are simply notes for humans. It's like things that the computer would ignore. It's like writing notes to a fellow programmer so that when they actually read your code, they can understand the functionality of what your code does. Now, this particular comment that we have here, the XPDS license identifier MIT, which you're going to see in every Solidity code or contract, is an indication. Like, it tells everyone that this code is an open source project, right? So it means you can use it freely. That is what this declaration means. And MIT that you see here is a type of license that means do whatever you want to do with this code. Now, for the second line, we have to also declare the version of Solidity that we're working with. And to do that, we simply have to do pragma. By default, if you hit enter, this remix will automatically suggest it, but because we're taking everything step by step, we have to say pragma Solidity, right? This is by this we're defining the version. Then we can do, I'll explain what this is. 0.8, let's say 0.8.0. We can do 0.8.20, but for now let's just leave it like so. So what does this syntax means? And we're going to close it like with this. Now, what does this syntax mean? Now, this syntax means that pragma is the Latin for practical. So it's like a fancy term, right? So this line is simply saying, hey, we're using Solidity version 0.8.20, right? Or never to compile this code. So what this means is we're using Solidity version that is greater than 0.8.2.0 to compile our code, right? So assuming I said never or new, I mean to say, let's say we had this like so 0.8.0. What this syntax will simply mean, I think this is outdated, that's why we're getting this error. Source file requires different compiler. It's telling us current compiler is 0.8.30, so that's why we're getting that particular error. So I can just use 20 because greater than this, so it means that you can pick from that 3 and 0. So what this syntax is saying is we want to compile our code with a Solidity version that is greater than 0.8.20, right? And that is what it means. Now, to create a contract, we need to do something like, so we have to use the keyword contract, right? Then we can do hello world, contract hello world, like so. Now, this is how we create a contract. The first step is to declare the contract keyword and to pass in the name of your contract. So with this first step, we've initiated the contract, right? Now, this particular keyword is like a class in other languages. Just in case you're familiar with some languages like JavaScript, it's like a class in other languages, or more like a blueprint for a house, So this hello world that we have here is the name we're giving our contract. And you can name it anything that you like. You can name it as your first contract or maybe awesome code. But also what you have to note here is that it must start with a capital letter, right? There must be no spaces. You can also use camel case, but there must be no spaces and no special characters are permitted. Now with this, we've simply initialized our first hello world contract. It's very, very important as we proceed. Now, the next step will be to add our next variable to this hello world contract. Now, let's add something in our contract that actually does something. Now, let's create a variable. So, a variable is like a box or a label, a box with a label where you store information, right? Now, to create a variable in Solidity, there are different types of data types, but let's just create this variable and call it string public. And I'm going to explain what this is and message. So, firstly, a variable is like a box where you get to store information, a box with a label where you store information. So imagine you have a box labeled message, and inside it, you put a piece of paper that says hello world. In this contract, with this logic, we're simply saying that this message is a type of string. Now, like I said earlier, there are quite a number of data types in Solidity. But by declaring message to be type of string, we are saying that whatever this variable will be storing would be a string. So this is the type of data. The type of data that we're storing here is string. Now, string, what the string means, like letters, like letter A, B, C. This is what a string is, right? Now that is a string. I can just comment this. So like we said earlier, comments are code that the computer itself or the editor or compiler would ignore. And also by saying public, we're simply saying that anyone can read what is in this variable. So it's like a window, a little window on the box that allows everyone to see inside. And we're going to learn about various Solidity identifiers. So in Solidity, we have different types of data type. We have different types of identifier. We have internal, public, private, and all of that. Then we're saying that this variable called message should be public, meaning everyone can see it. And we're saying that it's a type, the data type is a type of string. Now, if you notice, you're seeing a little red arrow here. And why is that? Because in Solidity, you have to end every of your declaration or statement with this. I can't remember what this is called. Now, this message here is the name we're giving to our variable, right? So this is words. You're correct. This is the data type. This is words, the identifier, and this is the name of the variable. So it's always important to use descriptive name so that you remember what you're storing in the box. And this semicolon, it means that we have to end the statement. It's like a period in a sentence, right? Now, there are different types of data types in Solidity. We have uint. We have data type of uint. We have the uint. Let me just write it out, right? Uint. We also have bool. We also have the bool. We also have address. Let's just talk about this in this right now. Now, what is a boolean or what is a uint? Now, a uint stands for, we also have ints too. I'm going to explain all of this, but let me just cover what a uint is. A uint stands for an unsigned integer. So a uint would only reference all numbers like 1, 2, 3. That is without signs. So that's why it's called an unsigned integer. Now, it means that there is no negative numbers, right? You can also not have quotes around it and all of that because it's not a string, and it's usually perfect for counting things or counting money, for counting things or amounts of money, because it's an unsigned integer. We also have bool. This bool means true or false, like a boolean. So it only has two possible values, which are what? True and false. Right, I'm going to comment this out also. True and false. Then we use the bool in situations whereby you want to store variables like is active, has access, is complete, and all of that. We want to know if is complete is true, or does the user have access, and that is where the boolean is very important. Now, talking about address, if you're somebody that is very familiar with the Web3 space, you would have heard of send me your address, what is the contract address, and all of that. Now, the address is like an email address, but for crypto wallets. So addresses, EVM's address always start with an OX, right? For most EVM chains, like the likes of Ethereum, let me not talk about chains in case you're new to cryptocurrencies, but we're going to understand all of this. But an address is an email address, but for crypto, is like an email address, but for crypto wallet. And it always starts with an OX and is always 42 character long. It's always 42 character long, and it's simply used to identify who has a particular wallet or something, right? It's like a wallet identifier. So it's like a Gmail address, but for crypto wallet. Now, how do we can see that we're getting errors in here like so. In here like so. I'm just going to comment this, but we're getting errors. And why are we getting errors? It means that we're just declaring this uint, but we're not saying anything. We're not assigning it to a variable. Let me use that word. Permit me to use that word, right? So let's say we saw here that this string, this variable here is named message. It's a public, the identifier is public, meaning everybody can see it, and it's a type of data string. Now we've declared a type here to be an unsigned integer. We also have to attach the identifier. Now, if I say public and I do age, now by default, when you don't declare the identifier, Solidity assigns an identifier to them, and we're going to talk about that as we move on. So, uint public age. So what we're saying here, if we say age is equal to 25. Now, with this logic, we're creating a variable here, right? And we're saying that the name of the variable is age, and it's a uint, an unsigned integer, and it's public, right? And we're storing age to be 25. Let's say we have this bool, so we can say public, or we can do is active, right? Or we can say is active is true. Then we always close with a semicolon. Then the address, let's say we do address public owner is equal to, let's just grab an address online, ethscan.io. Let's just grab this address. Now we can grab this address and just use it in here like so. So we've declared quite a number of semicolon to prevent that error. Now, you see how we have multiple variables in just one contract. Now, let me proceed to explain each type once again. So the string allows us to hold text, right? Also, it can take things like hello, pizza, as long as it's a string. Then we also have the uint, which is an unsigned integer, which is used to store all numbers. Then we have the boolean, which stores type of bool, true and false. And we also have an address. So it's like an address for crypto wallet. But if you notice something, there's a difference between this and all of this. All of this and just this. What is that? I want you to try and decipher what that is. Now, if you notice, age is initialized or set to 25, is active is set to true, and also the address is set to a particular address, right? The owner address type of owner is set to this. But if you look at message, it is not set to anything. Now, there's what we call initialization. Now, this is the starting value for age 25, for is active is true, and also for owner is this. Now, whenever you're creating a variable, you can decide to actually initialize it or not initialize it. It just boils down to what you want to build or what you need, right? Now, okay, now that you've seen that we can store data, how do we create functions? Or how do we use these variables that we've just created? Now, I want you to think of a function like a recipe. So let's say you give the function ingredient that is input, and the function follows a series of code or steps and gives you an output. Now, let's quickly talk about what a function is in Solidity. Let's write a function and call that function setMessage, right? Let's create a function. Let's say function and call the function setMessage. I'm going to explain all of this. So use the function keyword. You can call the function setMessage. There must be no space, right? Then we can pass in a param like this. You can say public. So we send the function is public. Now with this simple step, we've created the function. Now, what do you do in creating the function? You use the function keyword, then you define the name of the function. And in this scenario, we called it setMessage. There can be no space. There must be no space, right? Then we use this curly brace. Then we pass in the identifier for that function, right? Now, let's say we want this setMessage, just like the name sounds, we want it to set a message. But how do we know the message that it would set? So let's say, remember that I said that you should think of a function like a recipe. It receives ingredients, right? Then it processes some code, then it gives you back an output. Now, we have to, whatever logic or whatever code would run within this function has to be defined within these two curly braces here. So to do that, let's say we want to set a message. Whenever a user calls that function, we want to set the message to the message that the user passes in that function. So let's say our function is expecting an input of hello. Then whenever a user passes that hello, we want to update the variable that we have here at the top. So how do we do that? To do that, we can create, because we are expecting an input from the user that calls the setMessage function, this parameter, this curly braces here, is where we're going to pass in the argument, right? So we can just call the argument new message, like so, new message. But if you just pass in new message, we're going to get an error because Solidity always wants to know what this new message is, that is, what type of data it is, right? Then we're going to do string, right? Then we're still getting an error. We're saying that this message that user will be putting in when calling this setMessage function, the string, but we also need to pass in the type, right? So I mean to say, we also need to pass in, we've passed in the type. We also need to pass in where that function or where this particular variable is stored, the location where it will be stored. So because it's something that we do not want to like persist on our contract, we can just declare it to be memory. So what the keyword memory here means is that this is only useful when this setMessage is called. That is, we're not persisting it on our contract. So we're going to talk about different types of data location. There's the call data and all of that. Then there's There's the one that there's the private storage. There's some data that by default are stored on the block, on the contract, right? But this new message will be persisted on memory, meaning that we only want to use this new message whenever this set message function is called, right? Now, we can now proceed to set message, that is this variable that we have here at the top. We can proceed to set message is equal to new message. So what we've simply done here is we've simply updated the state of message to be whatever a user passes here in the function. Now remember that this message function, we're not just calling it out of thin air, we're referencing this variable at the top here. Remember that we did not initialize it to anything. So whenever a user calls this set message function, whatever they pass when calling this set message function now becomes the state variable that is stored here. So variables are stored in different locations. There are some variables that are stored in state, there are some variables that are stored in memory. Right now, state variables are stored permanently on the contract, but because we declared this new message to be memory, we only want to tap into the new message whenever set message is called, right? So we can also do something else. Remember that at the very top here, we did not initialize what message is, but we did that for age, we did that for is active, and we did that for address, right? Now, we can actually use another keyword called a constructor. And I'm going to also explain what that is. So we can just say constructor. Why I'm not tapping into it is because Remix will automatically suggest a constructor. Then I can do message variable is equal to hello world. Now, let's put on our debugging. Remember that as I hit Ctrl, I want you to notice that as I hit Ctrl S, this artifact files was repopulated. But we're going to look into that as we proceed. Now, let's put on our debugging glasses. We declared, remember that at the top here, we declared what message to be type of string. So it further means to say that whatever this new message would be must also be a string. So imagine I say uint. We're going to get an error that says data location can only be specified for array struct. Okay, because I'm using memory, right? It's telling me that, but memory was given. So let's say I just remove this and I do int message. It will tell you that you cannot assign a string to a uint. So it says uint56 is not implicitly convertible to explicit type of string because it means to say that this type do not match. So we have to say that it is a string, right? And also by default we have uint5, uint8. There are quite a number of unsigned integers that we have, but by default, if you do not specify the type of uint that you're using, Solidity will automatically treat it as uint256. So for best practices, it's just good to say 256. I'm going to explore the different types of uints that we have, but this is not our focus now. I just wanted to know that whatever you're setting to be the new state of a variable must also be equal to the type of that variable, right? So I can just do string and memory like so. Now, if you notice what we did here, in our constructor, we already initialized what message would be. Now, I want to explain what a constructor is. A constructor is a unique function that runs once when a contract is created. So in some code bases, you would see that people use it when they want to declare who the owner of the contract is and some other functions like maybe the symbol of the contract and all of that. The symbol might be a constant, so it might not necessarily be passed in the constructor, but people use it when they want to declare like the owner of a contract. So they tap into the message or sender and all of that. And we're going to explore all of these key terms. But now, I want you to see that we have a function that sets a message, right? We have a function that sets a message. Then this set message is simply expecting an input, and that input becomes the new state of this message variable that we have at the top. Remember that we did not initialize it. But in our constructor, we are setting message to hello world. So it means to say that if we deploy this contract, because the constructor runs once when the contract is deployed, what we would be expecting to be the message value will be hello world, right? Because this constructor is going to run just once. Then whenever let's say we now call set message function and we pass I'm famished. I don't know why I'm always famished. We would now then expect that the new value for message should be I am famished, right? Now, a constructor is a special keyword that runs only once when you first deploy a contract. Think of it like the setup when you first buy a phone, right? You have to turn it on. It turns up, like it runs the setup wizard and all of that stuff. It sets your time zone, your language and all of that. So it just runs once. The setup never runs again. So our constructor here helps us to set the message to hello world. Remember that our contract here is the hello world. Now, this set message function, this keyword here is very important. It's an identifier to declare that whatever will come next will be a function, right? Then this is the name that we're giving the function. This input itself must be a string because it must match the message type that we have that we've declared at the top. The public here means that anyone can actually call this function and all of that stuff. So we can also create another function. Since we have a function that sets message, we can create another function that gets message, right? So how do we do that? You can do function gets message, right? Then we can see that this function is public, right? Then if you just do something like this, and you do, because we want a function, because we want our message, we want to get our message, we can just do return message. But we're definitely going to get an error. We're saying that different number of arguments in return statement than in return declaration. So it means that the way Solidity works is that you can necessarily not just say, because we want to get the message, we're not passing in a parameter, right? We just want the message from the contract. But because we're using a return keyword, we have to also declare just after our public that this function is just a viewing function. We do not want to update the state of the blockchain. So in the blockchain, you can read data and you can write data. In reading data, you're necessarily not doing anything to the blockchain. You just want to see, it's like a GET request. You just want to read through, like reading through a book. But with a write, you want to write on a book. It means that you want to update the state of the blockchain. But because we just want to view, we want to get something, we want to see what messages, we have to declare that this is a view function, meaning that we do not have to spend money when viewing it. Then we also have to say that it returns something. Then what does it return? It returns a string, and this string, right, we returns a string like so. We also have to pass memory to the memory keyword. So that is that for that. With this function, we've simply initialized in our contract. We have two functions, the get message, and we also have the set message. So to recap, the view function here is the function that tells us that we just want to read data. We do not want to change anything. The return here is the function that gives us the string back, returns the message for us. And this is what specifically returns the message, right? So we're saying that it's a view function. We are expecting a string to be returned. Then this is what actually returns the message. So if I say, if I do uint256 and I remove this, I'm definitely going to get an error because this is returning a message and I'm passing in a uint256, right? So I can just pass it back like so, string and memory. So we have that. Now, the next step we have to do is, since we've written our first contract, like the hello world contract, we can actually now test and see if it works, if it compiles successfully. So on this left hand side, if you see this Solidity compiler, if you click on it, now we're going to see quite a number of things. You can see the compiler version here at the top. We see auto compile. Do we want to use auto compile? We do not want to use that at the time currently. Then we can click on compile hello world.so. Now, if I click on compile hello.so, you see that this is a green check mark, meaning that everything works just as it should. Compile hello.so, it means that our code logic is great. Then if the compile is successful, we can now proceed to deploy our contract. So just below this Solidity compiler, if you click on deploy and run transactions, now this is the VM. This is a virtual machine, a testnet. Although we have, this is a remix virtual machine. I mean to say, we have quite a number of them. On ETH Escrow, we have Sepolia. We used to have Goeli before it became deprecated. Quite a number of them. Then, for now, let's just stick with Remix VM, right? Let's just stick with Remix VM. Then, if we scroll down here, this is the estimated gas. We can set a custom gas and all of that, but we're not dealing with that. We're going to also cover what Way is, right? Way is like the standard unit of measurement in Ethereum. It means 1 exponential 18. We're going to cover what this is. Then, to simply deploy, we can just click on deploy. So, right below here, I want you to pay close attention to, we can see that the deploy contract is 0, transaction recorded is also 0, and in the terminal section here, we have nothing, right? So if you proceed to click on, I want you to pay attention to deployed and contract. If we click on deploy, we can see that we have a successful green check mark, meaning the VM blah 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 was deployed. If you click on it, you can see quite a number of details: the transaction hash, the block hash, block number, the contract address, the form and 2, right? Then you can see quite a number of things and all of that, but we'll be covering the bulk of these details later. But now you can see that we have one transaction, which is this transaction, and we also have the deployed contract. We can see hello world is deployed at this particular contract address here, like so, 0xDA, that is what we have here. So the contract is deployed at this particular address. So now you can see quite a number of things. You can see that we have the age, the get message is active, message owner and all of that. Now, to see whatever these variables are, you simply have to, if you click on age, you can see that age is 25, right? Because we've set age to be 25. We initialize age to be, so if you click on is active, what are you expecting? You're expecting what? It to be what? A Boolean. But I want you to pay close attention here. Now, remember that we mentioned that in the blockchain, you can either read or write. Now, when you read from a contract, you're not updating the state. You just want to see through, like reading through a book. But in writing, you're making changes on the note and you simply are updating the state of the blockchain. So you have to pay gas. So whenever we are reading from the blockchain, it is not seen as a transaction. It is not seen as a transaction. And that is why you see that the transaction recorded is just still 1, which is the first transaction that we had here at the top when we deployed the contract. But when we clicked on age, message, owner, we are not actually triggering a transaction. We're just reading the state of the blockchain. So whenever you're reading from state of the blockchain, you don't have to spend money. But whenever you're writing, you have to spend money. So that is the difference. Now, whenever you declare this as public, Solidity automatically treats it as a global variable. It's not a function, right? It's whenever you declare a function, whenever you declare a variable as public, Solidity automatically declares it as a function. Let me use that word. Yes, like a minimalistic function that can be accessible, and that's why it is appearing here at the top. I mean, at the hello world contract section. But if you notice, the set message is a little bit tainted, meaning that it's a write function that wouldn't require us to spend gas because we want to update the state of the blockchain. Now remember, when we clicked on message, we saw that it was hello world, and it was because in our constructor we initialized message to hello world. So let's try to, now the owner would be this OX address that we set here, and everything works just great. Now let's say we want to change this message. Remember that this message in here takes a argument, right? I mean, it takes a parameter. I'm using the wrong word. It takes a parameter, right? An argument is what you pass when you're calling the function. So it takes a parameter here called new message, and that is what we're going to pass here you can see that it has a little placeholder text, string new message. So let's say we say, I am famished. Our ETH sets message. We're expecting the message to no longer be hello world but to now be I am famished. So if we click on set message, we see that we've just triggered another transaction because we just wrote to the blockchain. We did not just read, we wrote to the blockchain. We can see that the transaction recorded has now been incremented to 2. Right? So if we click on message now, what do we expect? We're expecting what? Message to now be what? I am famished, which works just great. And I hope this is clear. So congratulations, pardon my English. Congratulations, you just deployed your first smart contract. Even though it's still on a pretend or a test, let me use the word pretend blockchain. The code is real, the process is real, but you just did what professional blockchain developers do. Now that you've learned the basic and core approach of creating a variable, compiling it on Remix, and also deploying it, I want you to try to do something. Let me click on File Explorer. I want you to try to do something. I want you to create a contract of my name called myname.sol and try to create a state variable that stores your name on the contract, then have a function that updates your name, and also a counter that tracks how many times you've updated your name. So I want you to pause this tutorial, even if you have to Google, just make mistakes along the way and try to do this. Give it a shot. So I'm going to walk around what I just said so that this approach of walking around Solidity sticks to more, right? So I'm going to create another contract here like so and call it myname.so. Did you give it a shot? So we're just easily going to say pragma. So it helps generate the prompt, and I'm going to say that the version is greater than 0.8.20. Then we can say contract, right, and say my name, like so. Then we can have a variable here of string and make it public, and it can be name, right? We can have a name. Then we want to also store the amount of times that you've made changes to that name, right? So we can create a uint 256, right? An unsigned integer, make it public also. Then say counter, call it counter. So this helps to track the amount of time you've made changes to your name. Now, we can also have a function in here where you get to update your name. So you can say function update name, right? Then what would this function take? It is expecting a parameter of the new name that you want to change this name to. So we can say string memory, right? Then we say new name. We can say new name, like so. Then we can say it's public, right? Now what we want to do is we just want to set name to be equal to new name. But because we want to track whenever we want to know the amount of times you've changed or updated your name, we can now do counter is equal to counter plus 1, like so. Alright, this should work. Then we also want to have a function of getName. Now there's something I forgot to say in the other one. If you notice, when we deployed in our hello-world.so, when we deployed message and we have get message, they were doing the same thing. So because we have this message here to be public, Solidity created it. They did these two functions here, get message and message, do the same thing, right? So this would return the message. It's like a function, right? Because it's public. That's what I was trying to say earlier, that whenever you declare a variable to the public, Solidity treats it as a function. So these two things were doing the same thing. Now, in our my name, we can easily just leave name, or we can just create a get name function, but let's just leave name as name. But basically we want this function, because if you say get name, it will still be doing the same thing as name, right? Because it's public. It's public, so we can just leave update name. Or rather, we can also say that this counter, we can also do counter plus plus, which is still the same thing as saying this. I'm just going to comment this out. So would that be all? So let's also use the constructor approach. Let's say on contract deployment, we want to set name to be equal to anonymous. Then on deployment, we want to set counter also to be equal to 0. Right, so let's try this. So what we had here is we have the version, the MIT license for this, and the version, the contract name, and all of that. So I hope you're able to give this a shot and work around it. So we're going to click on compile my name.so. It's successful, this green check mark. Then we can proceed to deploy. So the deploy is successful. You can see it here on the terminal, my name. Then if you click on deploy contract, we can also, if you click on counter by default is 0, name is anonymous as we did it in the constructor, right? Then we can now proceed to update the name. Let's say we want the name to be CWT, right? Then if we hit update name, we'll now see that the transaction goes through. Then if we click on name, we now see that name is CWT. I hope you're able to give it a try, and did you get it? So congratulations once again. So far you've learned what smart contracts are, that they are self-executing code. You've also understood the basic of Solidity and all of that stuff. You also learned about contract, pragma, and a constructor. A constructor is a unique function that runs only once on deployment. You learned about different types of variables, the uint, address, and all of that. Then you also learned about functions, both the view, the read and write functions. So let's proceed to the next step. In building a real payment logic, adding password protections and all of that stuff. Let's go. So if you finally made it here, it means you survived the core principles of understanding, creating variables, constructors, how to use functions and all of that. It means you've understood it, right? So welcome again. Officially, you're a blockchain developer. You wrote your first smart contract, you tested it, and you deployed it. So here we're building the real SecretPay contract, and not just a simple hello world or my name contract. We're building the actual password protected ETH transfer system. And by the end of this, let me call it session, you would have understood how to accept cryptocurrencies in your contract, how to store complex data like transfer details, how to use mappings, think of mini databases, and how to hash passwords securely, not in plain text, and how to also work with date and time deadlines. This is where things get exciting, and this is where your contract becomes much more useful, right? So imagine you're building an online store, right? But you need to store information about products, like the product name, the price, the quantity, and the seller. One thing you can do, I'm just going to comment all of this out at the time, is you can actually create separate variables like string, product name, 1, right? We can also do uint 256 price for item 1, right? We can also do ignore the red lines. We can also do uint 256 for quantity, and all of that for quantity 1, and before then the address of the seller, like so, and all of this approach, right? But think about it. What if we have 100 products? It's good. This is going to be terrible, right? Imagine we have to say string product name 1, then after this, we come down and we still do string product. We start changing it to string product 2 because we want to store quite a huge number of data sets that is up to the number of 100. It is terrible and also stressful. And this is where structs saves us. Now you might be asking, what is a struct? Firstly, I'm going to remove all of these and comment this code back in, right? Then let's head back to our file explorer and create a new Solidity file and call it SecretPay.so, right? Then I can just do pragma. I'm just going to copy what I have here at the top and paste it here like so. Then I'm going to do contract. There's going to be SecretPay. Now, just to mention, you can also use AI assistant if you're stuck. You can tell the AI assistant, like let's say on this my name.so, you can tell the AI assistant to explain contract, right? It's going to explain the current code of my name.so and blah, blah, blah. I just want to mention this in case you need clarity on something, right? So let's head back to SecretPay.so. Now, we talked about how you do not have to manage quite a number of products. Let's say you're setting up an online store and you have quite a number of products. You don't want to be creating price for item 1. You don't want to be doing it over and over again. And this is where the implementation of structs comes in. Structs spelled like this. Now, a struct is like creating your own data type that groups related information together. And I know this might be sounding very complex, but let's get straight into coding. So to create a struct, let's say for a particular product, we can do struct product, and I'm going to explain what this is. Product, right? Then I can say it takes a string of name, takes a uint 256 of price, and on side integer also a uint 256 for quantity, and also address of the seller. Then what else? We can also say, is it available? Is the product available? Now I want you to pay available. Okay. Now we have this, right? Now we've created a struct, a data type for this product, and you're going to understand now this product has name, price, quantity, seller, and all this is string and the data types, right? Now we can create variables of type product because we've defined this. And you're going to understand all of this as we proceed. So we can create a product. We can say product public. Then we can say item 1. Are you getting the gist? Well, we can also do product public. Then we can do item 2. Now, by simply creating this struct, this product type, now what is a struct? A struct gives us the functionality to create our own data type that groups related information together. So a struct allows us to create our own data type that groups related information together. Now, this means that this product is a data type. It has grouped this related information together for a product. Now, because we have this data type, we can now create items that inherit that particular data type. More like how in our name.so, we had string, we have name of type string, counter of type uint256. Now in our SecretPay.so, we now have item 1 that is type what? Is type of product, and we have item 2 that is type of product too. Now, we can also create a function. We use the keyword function. Then we can do create products. Now you're going to see where we're driving to. Just make sure that you're following. We can say public, right? We can do it like so. Now, would this be a read or write function? We're not just reading from the blockchain. We want to create, we want to update. It means that we have to update the state of the blockchain. So it's a write function, right? So in creating the product, we have to pass in parameters. Let's say in creating a product, we want to specify the product name, the price of the product, and the quantity. So we can do string memory. Strings, especially when passed in as parameters in the function, as well as stored in memory, because a string can be, how do I say it? For contract, it is computation. They store a whole lot of space computationally. So we just want to make sure that the location is clearly defined, that this name that we want to use here is of string. And I'm using this underscore here so that it is clearly different from what we have here, like name. And you see it by convention. When you're passing a parameter, most developers use the underscore just to indicate that this is a parameter. So this string, we want to pass in the product name. We also want to pass in uint256 of the price and unsigned integer for price, uint256. Then also, remember that I said you can just say uint, but it's just by default it's uint256. It's just good to actually specify that. Then also we can do uint256 and say quantity, like so. Right now we've passed in the parameters that we need when we want to create a product. So what do we have to do next? Now remember that we have item 1 here. We created a variable item 1 of type product, right? We can now say that item 1 is equal to products. This is how you create a new product instance. You can say name, this name here. Remember that this product has a type in it of name, a variable in it of name. So you can now say this name is now equal to the parameter that we pass in here as name, right? So it's not going to be equal to, it's going to be key value pairs like so, not equal to, I meant to say, sorry, we'll do price. Then we can also say price and also do quantity. Then quantity will now be quantity. So this is where things get a little bit more tricky. Then for this, we have to also use the semicolon, right? Then remove this. Quantity, QUA. So we are saying, now we're going to get an error. Now let's put on our debugging. It says, wrong argument count for struct. 3 arguments given, but expected 5. Now remember that this product struct, this data type that we created of product has 5 variables, 1, 2, 3, 4, 5, and we just passed 3, which is an issue. Now we want to know the seller and we want to know if the product is available, right? We want to know the seller. So how do we know the seller? Let's say we say address. Then we let's just pick a random address. Let's still use this. Then we pass it in here. Like so. No, the address does not have to be. We're passing it here like so. Then we say available, which is the last variable. Available. And we say true. Right? Because it's a type of boolean, so it's either true or false. It should not be in string like so. It should just be true, like so. So true. Then this should not be address. This should be seller, right? Now we're making progress. seller. Okay, this should have a comma. So we are making progress. Our code is fine. But what do you think is the issue here? The issue that we have here, the code is great. Everything looks good. But the issue that we have here is the approach on how we are handling the seller. What is the issue? With this approach, we're coding who the seller is. Now, I want you to pay close attention here, please. We want to dynamically know who the seller is. So, whoever creates the product should be the seller, logically, yeah? So, whoever is creating the product should be the person that would be the seller. So, on the blockchain, when people call functions, they do it via a wallet or via an account. So a private key, a signer. And I do not really want to go into the technicalities of all of that stuff, but whenever somebody wants to create a product on the blockchain, they need a wallet. And you might have heard of MetaMask, SafePal, Trust Wallet. You need on the blockchain to interact with contracts, you need a wallet, right? That's like the GU, like the nice, I already want to say graphic user interface, like the nice GUI that you have to use. Like you say a wallet, you click on send, you click on create and all of that. So to integrate, to interact with a blockchain, you need a wallet, right? But with this seller, we're coding who the person, that means it means that whenever a user creates a product, the seller will always be this person, and it's not okay because anybody can come to our contract and create a product. We don't just always want it to be this particular address. So how do we know the particular person that is calling that particular address, right? That particular person that is calling that, that's calling this particular function is known as the message sender. Now, as we dive into all of this, you're going to see that we use this syntax a lot. We also have the message.value and we also have the message.sender. Now, the message.sender is the person that is calling that particular transaction, right? And the message.value is the amount that is sent within that function. So the message.sender is the person calling the function, and the message.value is the amount that is being sent in that function. So with this message, by saying message.sender here, we have automatically or dynamically always get to know the person that is going to call this create product function. So if we click on this explain contract, I'm just going to say explain who a message sender is in details. So in Solidity, the message sender is a global variable provided by the Ethereum virtual machine that represents what's the message sender? The account that directly calls the function or the transaction. So the message sender is the account. Whoever account that calls this create product will automatically become the seller, right? And that is how it is done. So what we've simply done here is to explain this again. With this, we've simply created a template, like a form template. So it's like we're saying the product information form, the name, the price, the quantity, the seller, is it available, yes or no? So we're telling Solidity that, when I say product, I mean something that has these 5 pieces of information, right? So with this implementation, we can create actual products using this template that we have already declared at the very top here. So when we say item 1 is equal to this product, it's like we are filling out that form, right? It's like we're filling out that form, like we're saying this name here is now the name that we pass in as the parameter, right? And this message sender, once again, is a special variable that means whoever calls this create product now becomes the seller. So that is how this works. Now, for SecretPay, this contract that we're working on, what information do you think we need about each transfer? And this is where we start thinking about developers. Now, we just talked about the product, having an online store and all of that. So for SecretPay, what information do you think we need about each transfer? Think about it. So we want to know who sent it. Remember that this SecretPay, what we're solving is the logic of this project is to send Ether money to someone, Ethereum to someone, then the receiver must know the password that you've declared while sending that Ethereum. Then the person would input that password. Then that is the only time that they will be able to withdraw it if the duration is not elapsed, right? So in thinking about that, now that you understand what struct is, what are the things that you need, that you think that we would need when we want to use SecretPay for each transfer? We want to know who sent it, who can claim it, that says who is the rightful receiver. They want to know how much ETH is sent, what is the password. Now this password must be hashed and not just in plain text, and when does it expire, and has it been claimed? So the reason why I had to lay this foundation of struct is because we would need to declare our own data type, right? So we have to declare what the transfer structure. That means for each transfer that would happen on our contract on this SecretPay, we have to know what, who sent it, who can claim it, how much ETH was sent, what is the password, when does it expire, and has it been claimed? So I can just comment all of this out here like so, right? Then below it, I can create my own transfer struct, right? We can create our own. Let me use our own, not my own. So with transfer, right? Transfer. So the struct, what am I doing wrong? Oh, no, this should not be curly braces, right? So I'm going to create my own transfer. Why am I getting an error? Is it outside? Defining empty struct is disallowed. Okay, because I just be calming down. So I can just say address, right? Then I can say sender, address sender, like so. So we want to know who sent it, who sent the ETH. Let me leave this comment, right? Then we also want to know the recipient. So that would also be an address, right? So address of the recipient. So who can claim it? Who can claim it? Then we also want to know the amount using 256, and this will be amount of ETH, right? So remember that when we're about to deploy, we source way, and this amount is tracked in way. I'm just going to write amount in way. I'm going to explain what this is. Then also, we want to know the password. Now remember that this password will be hashed. It would not be in plain text. So the data type would be bytes 32. I'm going to explain all of this. You're going to see why we're using this. So the password will be hashed like so. Then hashed password, not in plain text. Then what else do you think? We need to know the deadline. So this is going to be a type that we can say deadline, right? Then also using 256. Then also we want to know if it is claimed, right? So it's going to be a boolean of claimed. So we want to know, has it been claimed? Has it been claimed? Right? Then the deadline will be what? You can just leave when sender, you can say when sender can get refund. So with this, we've simply set up a struct, our own unique transfer struct. And what does it help us with? It helps us to be able to, for code, for data type reusability, we do not have to always declare everything as if, like, it reduces the whole workload and stress in working around this, right? So with this, we want to know the address of the sender. We want to know who the recipient is, right? We also want to know the amount, and we also want to know the password, but it should be hashed, right? Then the deadline and all of that stuff. So what do you think we have to do next? Now, remember that I mentioned UIN256 earlier, that the UIN256 is more of an on-site integer. We have quite a number of them. We have the UINT8, but this is the default that Solidity use. So if we say UINT, it's still the same thing as UIN256. But because Solidity uses, for better code declaration, it's best that we use this approach. So 256 means 256 bits of storage. And it means that, it further means to say that it can hold huge numbers. That is from like 0 to, like, quite a huge, like from 0 to 935, I think. So you might ask that, why can it hold so big numbers? It's because ETH amounts are measured in Wei, right? So ETH amount, like I said earlier, are measured in Wei, and Wei is the smallest unit. So 1 ETH is equal to, let's just ask the AI, right? Let's just ask the AI. 1 ETH is equal to how many Wei? So 1 ETH is equal to 10 exponential 18. That is 1 quintillion in Wei, right? So that's what it is equal to. So 1 ETH is equals to 1,000,000,000,018 zeros, right? That is what 1 ETH is equals to. Now, that is for Wei, right? Now for byte 32, this is a different thing. We've not talked about it, right? So for byte 32, this byte 32 is a special type that is used for hashed password, right? So byte 32 is a raw binary data. It's a raw binary data, and it matches exactly 32 bytes. So it's perfect for when you want to use hashed password. That is when it's perfect for. So it looks more like 0x 2 blah 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 2d. That's what it looks like. So byte 2 is perfect when you want to use it with hash password. But don't worry about the other stuff. I'll explain it fully later. And this bool claimed means that by default, we can, if it's false, it means that it's not yet claimed. And if it's true, it means that somebody has already claimed it and all of that stuff. So by default, what do you think it should be initialized to? False, right? Now, we're already making progress. Now that we have our struct being set up, how do we now proceed to store multiple transfers? How do we proceed to store multiple transfers? The internet today isn't as open and simple as it used to be. Some content is restricted by location, websites track your every move, and managing multiple accounts can feel impossible without getting flagged. Whether you're trying to browse privately, access geo-blocked content, or securely manage multiple accounts, you need a tool that gives you full control over your online identity. That's where GoLogin comes in. GoLogin isn't just about privacy, it's about freedom, security, and control over your online experience. Here's what makes it different. GoLogin gives you access to restricted sites, streaming platforms, and services from anywhere. Also, unlike any browsers, GoLogin stops websites from tracking you, and it gives you the ability to easily switch between different profiles for work, social media, or business. You can also share accounts with your team without sharing passwords. GoLogin hides more than just your location, it protects your entire online identity. When you get to use GoLogin, you get 2 GB of free residential proxies included, It is fast and secure and access to content and gives you access to content worldwide. If you want privacy, security, and complete online freedom, GoLogin is the tool you need. Try it for free today. Click the link in the description. Now let's get back to the tutorial. Now we have our transfer struct successfully ordered, right? We tracked who the sender is, who the recipient is, the amount in Way. Way stands for 10 exponential 18, the password in a hashed format. We want to also know the deadline. These are the details that we need for every transfer that occurs on our contract. So we've set this unique data type using a struct that matches this series of needed details. So it begs the question, let's say a user makes a transfer. Let's say Alice sends ETH to Bob, and John sends to Jason. Now, quite a number of transfers. Let's say our contract gets popular, quite a few people starts using it, and at some point, we want to also, not even at some point, we want to also embed the functionality of tracking each transfer that occurs on our contract. More like creating a database schema or a structure so that for each transfer, we can easily check if it has been claimed, or if the deadline is passed, or if the recipient has actually received the fund. So we want to have a means whereby we can track every transfer that happens on our contract. Now you might think that we can easily, just like we did here at the top, by creating product item 1, which inherits the type of product, you can think that how about we do it like this: transfer, right? Then do public, then do transfer one, right? Then also we can just copy this too, like so, then do transfer 2. Then we can do it till we get to the 100th transfer. But this is redundant and it is very stressful. Really stressful. In fact, it's a terrible way to write code. We know that as developers, we want to do things in the most efficient way, and we also want to be more productive, right? So what we can do is we can implement something called a mapping. Now, a mapping helps with creating a schema in our contract, or like a mini database that we can use in our contract. So it helps us to solve the problem of always creating a transfer for every transfer that occurs. It helps us to solve the problem of creating a transfer variable for every transfer that occurs in our contract. So this is how we can use a mapping. Now, to use a mapping, before I go into writing that, think of a unique, a cabinet, right? Whereby you can always pull things. Let's say you have cabinets. Let's say you have 10 cabinets. Each cabinet has its own label. So you have cabinet 1, cabinet 2, cabinet 3, cabinet 4. So to pull details that are to see a particular details, let's say you have a tag also that is 1. To see all the details that is in cabinet 1, you simply just have to look into cabinet 1. Then when you put cabinet 1, you're going to see everything that is in cabinet 1. And that is what we want to do in our code logic. We want to use a mapping to create a unique ID for every transfer that occurs in our contract. So to create a mapping, we can simply do mapping like so. Then we use the mapping keyword. Now, because we want to use the ID, right, a number, we want to attach a number to every transfer so that when we check the number, when we check that particular number, we can see the transfer that occurred, right? So we can just, because it's a number, we can use a unt256. Then we use this particular if 4 equal to and a forward arrow 2 for that mapping. Then this unt256, this number matches a particular transfer that occurs, which will follow this data type, right? transfer, then this mapping will be public, meaning anybody can see it, right? Then we can call it transfers. So this is a variable here, a mapping variable that maps a uint 256 to a transfer. It means to say that what this mapping simply does is that it maps a number to a particular transfer, right? It maps a number to a particular transfer. So it maps it like to Bob, to Alice, then to the amount that Alice pays, right? 100 ETH and all of that. So what this does is that whenever we want to get a particular transfer, the details of a particular transfer, by simply knowing the ID, which could be 0, 1, 2, 3, 4, 5, so down to 999, or it could be 1, 2, 3, 1, 5, 6, we can get the details of that particular transfer, right? And it's as simple as it sounds. So a mapping uses a key, right? It has a key and a value. So by knowing the key, you can get the details of the particular value. Now, how do we, let's say a transfer has occurred, a transfer we map in 0 has occurred, and we want to know the details, we want to know the sender for that particular transfer, but we know that the ID of that transfer is actually 0. We can simply do, if we okay, let's say we want to know the sender, we can do address, right? We create an address variable of sender, then we do is equal to what? To know that particular sender for that particular ID. Since this transfers is the variable that stores the mapping, we can do transfers, then pass in, using square brackets, pass in the ID, which is 0 in this instance, in this analogy, then we'll just do dot sender. So with this logic, we already know who the sender is. We can call this transfer sender. So with this logic, we already know who the sender is. How about if we want to know the ID? Let's say we have another transfer which ID is 1, and we want to know the amount. How do we go about that? We can do uint 256, right? Uint 256, then we can do amount. We can say amount sent is equal to transfer, the transfers at mapping at ID 1, right? They will now do dot amount. So with this approach, mapping gives us a database-like ability to know the mapping, to track a particular transfer that occurs at a particular ID. So just to reiterate, this transfers is a variable of data type mapping. Then what these transfers always expect is an input of uint 256, and what it gives you is an output of transfer, right? So it takes an input of a uint 256, which could be 0, 1, 2, 3, 4, 5, and it gives you back a output, right? That is how a mapping actually works. So I'm just going to comment this out here like so. I'm just going to say to get the transfer sender at ID 0. That's the logic. Then this would be, what would this be? This would be to get, right? To get the transfer amount at ID 1, right? To get the transfer amount at ID 1. So this is how mapping actually works. And we're going to use it a lot as we proceed. So if you want more clarity, you can also ask AI here on the platform to break down what mapping is to you. And now that we understand what mapping is, we can now proceed to talk about what is called payable. Now we want to understand what payable functions are. let's quickly talk about that. Now, a payable function is a function that allows us to receive Ether, or allows us to receive Ether. Yes. So this is a very critical concept by default, and by default, Solidity functions in themselves cannot receive ETH. So let's say we have this my name function here. It cannot receive ETH if we do not assign a particular keyword to it. The hello world to the get message, set message, they can't receive ETH by default, right? So to accept ETH to a function, we have to use a magic keyword called payable, P-A-Y-A-B-L-E. So if you try to send ETH to a regular function, it would fail. It will fail. So let's say we have a function called normal, right? And this is how we write our function. We do it like so, right? Then we say public. This is a normal function. By default, this function cannot receive ETH, except if we use a unique keyword to allow that. Now, let's create another function and say receive ETH. Let's just say receive ETH. Now, if we say this function is public, like so, as at now, this function is the same thing, right? It's in no way different from the normal function at all. But once we use the keyword payable, it simply drives home that this function can now receive Ether. So this function can receive ETH, but this cannot receive ETH. And note that this ETH that is received is stored in the contract. So the payable keyword, I mean to say the payable, P-A-Y-A-B-L-E, this keyword here is like putting a cash accepted sign on our function, right? So when somebody calls a payable function, they can include ETH within the transaction or with the transaction, right? So for instance, when somebody makes a payment, how do we know the amount? This is like when we use the word payable, it's like we are putting a tag that cash can be accepted or cash is accepted. So how do we check the particular amount of ETH that is sent or that was sent in that transaction? If you remember in our hello world, in our there's a place where we used a particular message.sender. I'm trying to remember where we used message.sender. Was it here? I don't know why I can see where. I'm trying to remember where we've used message.sender, except if I have taken it out. Okay, remember that in our SecretPay here, in the create product, we used the message.sender, and I said that the message.sender keyword is a unique keyword to know who calls this function called create product. Now, to also know the value that is sent when this function is called, we can also use the message.value. Now, this message.value helps us. We can use the message.value. Now, the message.sender is the person calling the function. The message.value is the amount of ETH sent. This is the amount of ETH sent. Remember in way, and way stands for 10 exponential 18. Right? So this message.value helps us to track the amount of money that is spent in the transaction. Now, one thing we can do is we can create a uint56, right? uint56, then say amount sent. Let's create a state variable in this function. A variable. We say amount sent, right? We can say amount sent is equal to what? Message.value. Now this is 1 of 1, right? Amount sent is equal to message.value. This one is because we've not used it on use local variable. Now we've created a state variable amount sent to track that is equal to message.value, right? That is the amount that is sent in this transaction. Now we can now enforce like a conditional statement that says if the amount sent is not greater than 0, we should say you must send ETH, right? So it's like a conditional statement in other languages. And to do that in Solidity, we can use the require state keyword. We can use the require keyword and say if message.sender if message.value is greater than 0, don't throw an error. But if it is not, you can say you must send ETH here like so. So what does this logic here, this logic that we've written here, so rather than saying amount sent, rather than saying message.value, since we already created amount sent at the top, you can just say amount sent must be greater than 0. So what does this mean? If everything in this block goes through, right, this does not have to go through. So it is only when everything in this block does not correspond. If the declaration here is not true, this would now be triggered. That is what the required statement does. So if the amount sent is greater than 0, you will not get this error that you must send ETH. But if the amount is not greater than 0, you will get the error. So if the amount sent is greater than 0, you will not get this. But if it is not, you will get this. Right? That is how the required statement works. Then as we proceed, you can also create error. We can create our own custom error messages and use conventional if and else. But for now, the required statement we're okay with it because we're just diving into the world of blockchain. So the message.value that we have here is a special variable that tells you how much ETH came with the function call. That is how much ETH was sent with the function call. Now, remember that we've set amount sent to be equal to message.value, and we're checking that this is true. Now, also remember that we talked about the message.sender. Now, the message.sender is the address of whoever called that particular function. The message.value is the amount of ETH sent in way. We also have one more unique thing that we've not talked about, and that is the block.timestamp. Now, this block.timestamp is the current time in seconds. So it's the current time in seconds since 1970. And you might be triggered. What do you mean by since 1970? We're going to look into that in details, right? So everything that we've declared here is super useful. To accept ETH in a function, you must declare that it is payable, right? To track the amount, you must also use the message.value, which helps us to do that. Then we use the require keyword to enforce operations. And all of that. Then we also talked about the block.timestamp, which helps us to get the current time, and it's the current time in seconds since 1970, and we're going to explain what this is. So this normal function here in itself cannot receive ETH. Why? Because it does not have the payable keyword. So that being said, let's proceed to creating the transfer function. Now let's talk about, before we create the transfer function, let's talk about events in Solidity. Now, events are like notifications. They help us to create a permanent log on the blockchain. And to create an event, we use the keyword event. Then let's say whenever a transfer is initiated, we want to create an event of transfer created, right? Transfer created. So to create an event, we use the event keyword, then open bracket, then we pass in the values of the event. We want a UN256, like so. Then we want this particular value to be indexed, that is the transfer ID, and I'm going to explain what this is. Then we can also index the address of the sender, and we can also index the address. Remember that these are the things that we need. Remember that in the transfer struct, we have the sender, they have the recipient, we have amount and all. But we want to index the transfer ID and the address of the sender and the recipient. What's the spelling of recipient? Recipient. Also, what do we want to do? We also want to pass in the UN256, the amount, and also we want to pass in the deadline, UN256 for the deadline, like so. So we have this event successfully created. Now, what does an event do? Now, events are like notifications. So they help us to create a permanent log on the blockchain. And why do we need events? So events helps us to, it helps other applications. Like let's say a front-end Web3 developer wants to check for things that have happened on our contract. It helps front-end application to listen for them. And it helps to create like filtering, like searchable history about things that have happened on our contract. And for easy filtering, they are very, very important for easy filtering. So for instance, when we have these indexed parameters, it means to say that the transfer event, that is this transfer created events, can easily be filtered by the transfer ID and the sender and the recipient, because these are the indexed parameters, right? Now, what that drives home is that we can easily filter a transfer that is initiated by using the transfer ID, which we mapped to the transfer here, right? So we're going to go deeper into the rabbit hole as touching events, but events helps us to actually create notifications on our contract simply. So what we're going to do is that in our create transfer function, whenever a transfer is successful, we want to emit an event. And the index keyword here is that we are putting attention on this parameter so that we can use them for easy filtering. This is what this means easily. And you're going to understand that very soon. Now, how do we, let's push it to create the transfer function. Now, to make our code much more easier, I can move all these comments to the top here, like so. Then also move this to the top. Let's create our transfer function. So how do we create a function? The first step is to the first step would be to use the keyword function, right? Function. Now, what do we want to do at first? Remember that we mentioned payable, right? We mentioned the word payable, and we said that whenever we use the word payable, it's like we're attaching a tag that this function can accept ETH, right? So we can create the function and call the function create transfer, like so. Now, this create transfer function is definitely going to take in, we can say public, right? Like so. Now, this create transfer function is going to take in some parameters, right? So whenever we are calling that particular, whenever a user or a particular person is calling the create transfer function, they want to specify the recipient who would be receiving the money, right? The password, because of the logic that we're using in this blockchain implementation, it's a SecretPay. We want to pass in the password, and the recipients must know the password to be able to claim the funds, right? And we also want to pass in the duration to know if the recipient has claimed the funds within the specified duration that we specified when calling the create transfer function, right? So it takes a parameter of address, right? That is the recipient, the person who is intended to receive the money. Then also takes in what? A string of password. The password would be a string, right? Memory then password, right? Password, then also duration in 256 and duration. Like so. Now, if you notice, whenever you're using string, whenever you're passing a string as a parameter, because it is computationally expensive, you have to declare the location where it will be stored. But you necessarily do not have to do that for this address, right? And for duration for U256 is usually done for strings, right? Because we have to specify where they have what data location they would be treated with. So this would be treated in memory. So this password would only be treated in memory, right? Now, that is that for strings and all. Now, what will be the next step that we have to do? We have to declare this function to be payable, right? Payable. Then we want to initiate a transfer, right? We want to send Ether, right? Now, the first step, what we can do is, I do not want that sidebar. What we can do at the moment is to enforce certain rules. Remember we talked about the require keyword here, whereby we can use it to enforce operations. So we want to validate that whenever a user or person is calling the create transfer function, they are not just sending zero value of money or 0 ETH. So we can use the require keyword, right? And say if message the value is greater than 0, if message the value is greater than 0, right? If this works, it's okay. But if it does not work, if the message of value is less than 0, we want to say you must send ETH, right? Then we use a semicolon here like so. Now, we've enforced this validation, right? Now, what will be the next step? We also want to ensure that the password that is being sent. So we want to ensure that the password that the user sent is, we want to ensure that the user passes a password, imputes a password, I mean to say, right? That we want to ensure, remember that we said that the password is stored in bytes of 32. And we said that this byte 32 usually is when we want to hash a password. And we're going to explain that also. So we can do require what are we going to do? We're going to do require bytes, like so, then password, right? This password is what is sent in the params. Then we can now check if the length is greater than 0. Length is greater than 0. So with this implementation, we want to be sure that the password that the user is imputing is actually greater than 0. That did they provide the password, right? I hope it is not empty. That's what we're trying to enforce here. So if the password is empty, that is, if the length is less than 0, we do password cannot be empty. I say please provide password. Then now I want you to pay attention here. If this is true, right? If password is greater than 0, this would not happen. But if this is not true, if it's falsy, this would happen. That is how the require statement works. Now, we also want to ensure that they provide a duration, right? So we can do require duration to be greater than 0 because the duration is a uint. This should be like so. Then you know what the method of value is. The method of value is the amount that is sent in that payable function. Then if we say duration must be positive, right? I'm going to say duration must be positive like so. Then the recipient, we're going to talk about that, is saying that we've not used the recipient. And why the error left the duration is because we've used it. But the recipient is telling us that unused variable. Right, we're going to use it. So with this, we've enforced certain things. We've enforced that user sends ETH. We've enforced that the user provides a password. We've also enforced that the duration must be positive. So now the next step will be to hash the password that the user specifies. Now, how do we do that? Now, we do bytes 32. Remember that we've talked about byte 32, so how it is important for hashing password. We can do password hash. We can do password hash, right, is equal to now ksac 256. You're going to understand what this is. KSAC 256. We use the ABI.encode packed. Yes, we use the ABI.encode packed. Then it takes in an argument of password. It takes in an argument of password like so. Now you might be wondering that what does this do? How is this important? And this should not be here. This should be here. Now, this is a very important step. And why is this important step? Now, we need this because if we don't use the password hash, it means that everybody is going to give us a problem. And that problem will be that everyone can see the blockchain data, right? And anybody can see, oh, the password, let's say the user uses a password of secret123 or secrets, or uses a password of secret123. Anybody can see that, oh, this is the password specified because it is public, it is transparent. They can claim the transfer before the recipient does. So let's say somebody creates a transfer. Once the person calls this function without hashing the password, they can see what the password is and they can claim the transfer, right, before the recipient actually does it. Now, the secure approach is to store that particular password as in hash format, and it's going to, remember that we said that it outputs, the hash output stuffs in 0x blah blah blah. So this string would then now be hashed as 0x23d blah blah blah, stuff like that. Now, when an attacker sees it, they cannot actually decipher what this was initially. So when the attacker sees it, they will be, the next question they would ask is, what password creates this hash? And it is not reversible. They can only try to guess and check. Now, the way hashing works is that whenever you input the password, it generates this process, this KSAC. We're already looking into it. Whenever you input this password, it outputs a hash. And the key properties of this KSAC ABI encoded pack is that, firstly, it always gives the same output, right? And it is one way, meaning it cannot be reversed. So different inputs would actually give different outputs, but it is actually deterministic, meaning that it would always give the same output, but different inputs will mean different output. So whenever the user that is created this transfer enters this secret123, we are going to hash it using this KSAC 256. This is what we use to actually hash the password, right? So we use this particular function, it's the blockchain function, to actually hash a password. And we're also going to use it when the user wants to claim, right? We're going to use it to actually compare if it matches, right? So this KSAC 256 is the hashing function itself. The ABI encoded pack now converts the string, this particular string, to bytes so that KSAC 256 can process it. Because if we don't pass this in here, the KSAC 256 will not be able to process it and we're going to get an error. Because this KSAC 256 is expecting a byte, right? Now, the KSAC 256 is the functionality in itself that hashes the particular password. But what this ABI encoded pack does is that it converts the string to bytes, and you can read more on this. So this is how we implement hashing in Solidity, right? Now, with this process, we've simply created a password hash, right? I hope that is clear. The next step would be to actually now calculate the deadline. So we can do, the deadline is in uinterfaces and unsigned integer, right? We can do uinterfaces. We can say deadline is equal to block.timestamp plus, now this block.timestamp, remember, is the current time, then the duration. Remember that we said since 1970. So if you come here and you just add current time in Unix, So it's in Unix. You're going to see that the current time is 176. This is the current time around 427, right? So it just helps us in blockchain terminology. This is how we get the current time. Then we had the duration. So let's say the user says 24 hours. We had the duration to this block timestamp. And we're going to see how that works also. Then to actually, I think I would love to, so let's say let me buttress more on this. Let's say the current timestamp, let's just copy this, is this. Let's say the current timestamp is this, right? Going to comment this so we know it's a comment. Then the user now says 24 hours. So 24 hours times 24 hours in second. 24 hours in second will be what? Let's check. 24 hours in seconds. Okay, 24 hours in seconds will be 86. Okay, it's 6,400, right? So it will be 86,400. So this would now be the deadline. So the summation of this would be the deadline. So this is, 24 hours. 24 hours, right? So that is how we actually enforce the deadline. Now the next step is I'm going to leave semicolon here. Then the next step, we're getting this warning because they are unused local variables. And a local variable is a variable that is stored within a function, right? That is what a local variable is. Then there's a global variable. A global variable are variables that are accessible by all functions, right? So they are not limited within the scope of a function. Now, the next thing that we can do is we can now proceed to store the transfer, right? So to store the transfer, we can actually, now how do we store the transfer? Remember that we said that mapping acts as what? Mini databases. Mappings. Where do we have mappings? Here. They act as mini databases, right? So what we can do here, is that we can store for every transfer. Once the transfer is created, we want to store it in the mapping, right? We want to store it in the mapping. So we can do transfers. Now remember that we called these transfers. This is the mappings here. We called it what? Let me just remove all this space so that we can see everything. I can remove this normal. Then I can also comment this out. Now the mappings here is called transfers, right? So we want to also store this particular transfer that is initiated in the mapping data set. In the mapping data set, we do transfers, right? So we can do transfer counts. Now we need a transfer count to easily attach a mapping. Now imagine that we want to store this particular mapping, this particular transfer in a mapping of 0, like in a ID, in this U256 of 0. Remember here that we are mapping a U256 to a transfer struct data, right? Now imagine we do transfer 0 is equal to transfer, right? Now remember that we said that this transfer struct is like a form data, and it helps us to easily create another transfer data, right? So we want to easily fill the transfer form, that is the struct. Now we're tapping into the transfer struct here at the top, right? Then we're saying the transfer has what? It has sender, recipient. So we can say the sender is who? The message of sender, right? That's what it's going to be. The sender will be the message of sender. Then also the recipient, it has a recipient. The recipient will be, that will be recipient, like so, right? The recipient will be recipient. Also, it also has amount, password hash, and all. So what would the amount be? The amount would be the message or value. Then what else? The password hash should be what? Password hash. So to prevent I can just call this like so. I'm going to leave it like this since it's not a parameter. Password hash. Then what else? It also takes in the deadline. So the deadline will be deadline, right? Deadline will be deadline. I'm going to explain what all of this is. Then what was the last one? claimed will now be true. The claimed will be false. By default, it should be false, right? Because we don't want to see that user has claimed it when they've not claimed it, obviously. But we're getting the error, and we're going to fix this. So it's saying amount does not match function declaration amount. So the amount is U256. The amount does not match. Okay, amount. So it should be amount. Right? That was like a spelling error, man. So we have this and it's great. But I want you to pay close attention here. Imagine that while we have this transfer count here at the top, while we have this transfer function here, we're enforcing this our transfer function, our create transfer function is not dynamic at all. And why is it not dynamic? It's not dynamic because we are coding every transfer to just replace the U256 at 0. Remember that this U256 of transfers maps to a particular transfer. Right? So what we want to do is, rather than coding this to 0, we want to use a variable that updates itself dynamically. Right? We want to use a variable that updates itself dynamically. So what we can do is that we can create a transfer count variable at the top here. We can do uint256. I'm going to do uint256 and call this public and transfer, and use transfer count here like so. Now, why is this important? You might ask. When we say transfer of 0, now remember that this is a mapping, and we're saying the mapping at the uint ID of 0 is equal to this particular transfer. Whenever a user calls this create transfer function, we're enforcing that the new anybody that, let's say somebody comes, they call the create transfer function, this transfers mapping at 0, uint256 becomes this. If another person calls this transfer function, it now becomes this again, which is bad. It keeps on replacing just the one at ID 0 and does not populate other IDs from 0, 1, 2, 3, and 5. But we want to always populate this. So rather than coding this, we can just pass in transfer count here like so. So we can proceed to always increment the transfer count. So we can create a constructor too. We can create a constructor that initializes transfer count to 0. So this constructor runs only once, right? And it initializes the transfer count to 0. So we're making progress. Now what we've done is that we've actually stored this transfer in the mapping. We've stored the transfer in the mapping. And what we can do next is we can now emit an event. We can proceed to emit an event. Now, how do we emit an event? Remember that we declared an event at the top here. Like so, we declared an event to have the transfer ID, sender, recipient, amount, and deadline. So how do we now, whenever a user calls this create transfer, we enforce all of this. We ensure that the amount is greater than 0, the password is provided, the duration also is provided, and it's positive, that is greater than 0. We hash the password so that it cannot just be seen by anybody. We create the deadline and we store the particular transfer in a mapping. Now we want to emit an event. Now events are like notifications. It helps to actually create series of things that we've done on the blockchain, and also help other apps to know what is going on in our contract, right? So to use an event, you'd use the keyword emit, then we do transfer created. So you use the keyword emit, then you pass in the name of the event, and the name of the event that we created was transfer created, right? Then we pass in the data. So what is the transfer count? Now what is the event ID? We can, since we're using this transfers count as the ID now, that is the uint for this particular mapping. You know, this mapping takes in a uint, this transfers mapping takes in a uint of 256. And in here, we're using the transfer count now as the uint 256. We can proceed to say that the transfer ID would now be the transfer count, right? Transfer count. Then what next does the event take? The event takes in a sender and a recipient. So who is the sender? The message.sender, the person who is calling the function. Then who is the recipient? The recipient is this person here, like so, right? Recipient, but the parameter passed in the function. Then the amount, it takes amount and deadline. So the amount is message, the value. Then also the deadline is the deadline. All right, this is the deadline here. We created this variable here. So this also should have a semicolon. Semicolon, we do not have to pass this comma. So with this, we've finally created our create transfer function. And I know that it might be a little bit of, it might be cumbersome to you, but we can actually, let's just copy this and ask the AI to explain it to us. So explain this function in details, right? I want you to do the same thing. Now hit enter. That's what we have. So this function lets a user lock ETH in the contract and send it to a recipient later, but only if the recipient knows the correct password. If the recipient doesn't claim the ETH before the deadline, the sender can refund it. Think of it like a password protected escrow service for ETH. But it's giving us all of this explanation. So it's telling us that the payable function accept. Okay, so it goes on to explain what this payable function does. It tells us that it allows us to accept ETH, store the method of value, and all of that. You can like look more about this into there. I think it breaks it down totally, right? But I'm just going to explain it once again. I'm going to go through it once again. Now, what we have here at first is that if you notice, this function takes in a parameter, right? So this recipient, the first one is the recipient, the person who can claim the ETH. Now, the password is the secret, right? But we hashed it, right? The password is the password, right? The second one is the password. And the third one is the duration. That is the second until the sender can actually take his money, can refund it, can take his money back, right? Then the underscore that we have here is like a naming convention for parameters, right? So that it does not like, we do not mix it up with what we have in the struct or in other variables that we declared previously. So the public keyword here shows that anybody can call this create transfer function, and the payable means that we can send ETH along with this function. Ethereum can be sent along with this function. Then the first step here was that we actually validated. The first step here was validation. Now, what did we do? We actually enforced that these processes should be true. If not, this function would not go through. I don't want to use the word revert. Revert is another approach in Solidity. We were not using revert at the time because we were not creating our own custom errors. We're just using the require keyword, which is simple to use and to understand at first. But if you go dive deeper into Solidity, you're going to understand all of it. So the first validation is that we're requiring that the value must be greater than 0. That is, the user is sending ETH in this transaction, just an extra check, right? So this require statement is like a bouncer at a club. So if the condition is false, the transaction would fail. So if this is false, that is, if method of value is less than 0, it will fail and to tell you must send ETH. If this too is false, that is, if it is less than 0 and not greater than 0, the tell you password cannot be empty and all of that. And the same thing for duration. Now, we also explained the hash password. Is that we explained that this is expecting this KSAC 256 itself is what hashes the password, but it is not expecting a string directly. It's expecting a byte to work. That is why we use this ABI.encode pact to convert this string to a byte, and it now proceeds to hash the password. And we also said that it's a one way, it is irreversible, right? And it is deterministic. That is, the same input will give you the same output. Now, that was the other step that we did, right? That was the second step. So the second step was to actually, we're going to leave a comment here like so. Second step was to hash the password, right? Second step was to hash the password. Then we did the next step was to actually create a deadline like so. Then we now stored the transfer. We stored the transfer in a mapping. So we created the deadline. The block timestamp is the current time. We checked it here in the current time unit. You can just search this to know the current time. Then the duration, we had it plus the duration. Then also, what did we also do? We now mapped the transfer we stored the transfer in our mapping, right? That was what we did. So we stored the transfer in our mapping, and I proceeded to explain that this transfer count, we created the variable here, transfer count, and we initialized it to 0 in the constructor. The constructor just runs on deployment once. Then we're storing it at the current value of the transfer count, right? Then we're now creating the transfer object, or we're creating the transfer instance. So it means that at this transfer count, whatever this user passes as the recipient and the details here now becomes that mapping, right? Now becomes that mapping, and that is how it works. So we mapped every transfer that is initiated, that is called, to the transfer mapping at the current UIN256, at the current ID. I hope that is clear. Then also we now proceed to emit an event. So we also emitted an event. So one thing, what do you think we've not done? What we have not done is that with this our implementation still, remember that we initialize transfer count to be 0. So whenever a user calls create transfer, it means that at this mapping, this transfer mapping at 0 will be equal to this. If another user still comes to and calls create transfer, whatever parameter they use in that particular transfer, the ID, the sender, the recipient, will still be this 0 because we just saved transfer count as 0. What we have to do is that whenever user now calls this create transfer function, we can now increment the transfer count, right? And that is what we should do. So we can just do transfer count plus. So this helps us to always change the value of transfer count. So let's say the first user comes, he calls create transfer, it will be at 0, right? Because we initialize it at 0. But immediately this create transfer is done, transfer count now becomes 1. If another user comes and calls create transfer, the mapping of that current transfer that the user calls will now be stored at transfers at mapping 1, right? Then it will then increment to 2. If another user comes and calls create transfer, it would now be 2. It will store the mapping of that current transfer at 2. So if you want to easily get whatever transfer details by checking the mapping, by passing in the UIN256 that matches that particular transfer, we can get the particular transfer details. I hope that is clear. So it is very important that we actually also increment transfer count. So with this function, we've successfully been able to actually create the transfer method, right? And what other things have we not covered? I think we've covered everything so far, right? So look at that. You've come a long way. You created a contract that can actually accept ETH, right? You also learned how to hash password. You also learned how to calculate a deadline, right? You also learned how to create a deadline. So you've come a long way, actually. What I would just say is, just make sure that you ruminate on these details. If there's anything you do not understand, you can actually interact with the AI platform here. And so now, with this create transfer function, the user can lock the ETH and no one can touch it until someone either actually knows the password and claims the amounts with the correct password, right? So this is very, 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 very important as we proceed. So what will be the next step? We also now have to learn how to create the claim and withdraw, claim and transfer function. Now we've simply created the create transfer function, right? But what about the person that ought to receive the money? What do they have to do? So we have to proceed to implement that functionality also. So in summary, you've learned how to create your own custom data type using structs, right? You also learned about mappings, right? You also understood what a payable function is, and you learned the KSAC 256 hashing, password hashing methodologies. You also learned about blocked time handling in Solidity, and very important, events, right? So we've come a long way, right? And as we proceed, let's dive into how to create the claim transfer function and all of that. Let's go. So we've come a long way, and this is where everything starts to come together. Right now, our contract can actually lock ETH with a password, and it's actually very cool, but it's still kind of useless if no one can ever get it out, right? So we would be adding important functions to our implementation, right? So we want to have a functionality whereby a user can actually claim transfer. That is, the person intending to receive the funds, right? So we can create a claim transfer function and say it's public, right? Then we can also function like so. Then we can also create another function and call it refund transfer. So in a scenario whereby the person that sends it wants a refund, right? Can refund it. Let's say the deadline is passed and all of that. So these two functions are very, very important to our code logic. Now, there are things that we have to actually ruminate on. Firstly, to understand how this claim transfer function, to understand every of the logic that we want to pass in this function, we want to actually get to know the logic behind the claim transfer. What has to happen? And that is how we as developers, that is how we think. Before we just plunge into coding, we want to actually understand the workaround, right? So firstly, we want to actually check that when the first step would be that a user would call the claim transfer, right? User will call the claim transfer. Then we want to check if the transfer that the user is calling does exist. So if it does not exist, we want to revert with the require with an error, right? Then we want to tell the user that the transfer does not exist. Then if it does exist, we want to continue. Then the next step will be to actually check if they've already claimed that particular transfer that the person is calling. Just because users can be phony, we have to ensure that we do our best while writing code. So we want to check if it is already claimed. If it's not already claimed, if it's already claimed, we want to tell them that it's already claimed. There's an error. If it's not already claimed, we want to check if the person the message is sent, that is the person calling it, is actually the recipient. That is, the caller is the recipient. Then if the caller is not the recipient, we want to revert that, no, you are not the recipient. But if the person is the recipient, we want to continue. We want to check if the deadline is passed. We want to also check for quite a number of things. We also want to check if the password is correct, right? And all of that stuff. So it's important that we try to understand the whole code logic for working around the claim transfer function. So what do you think is the first thing that we can do? Now, whenever a user initiates a claim, it's important that such an event is very important, it's very germane. So we can also create a claim transfer event so that whenever a user carries out a claim, we log it on our contract, we log it on the blockchain. So we can create a event called transfer claim, right? So we can create this event. I'm just going to copy this for the sake of time and paste it here. Then I'm going to change it to transfer claim. Now, what does it take? It's going to also take a ID, right? We want to know the recipient and want to just know the amount. So we just need these 3 parameters, right? So we'll be filtering by the transfer ID and the index. So this would be easy to work around like so. Then the next thing would be to start working around creating a claim transfer function. So how do you think we can go around this? Firstly, this claim transfer function would need to take in the transfer ID as a parameter. So we can do uint256, right? Transfer ID. We'll use this to check the transfer, if the transfer does exist, right? Transfer ID. Then we can do string. We can also take the password. We need the password, right? So I'm going to use an underscore just here. So we want to know the password too, right? So the first step is to our first step would be to get the transfer, to know if it does exist, right? That the person, the caller, the transfer that the caller is trying to claim does exist. The transfer that the caller is trying to claim does exist. So how do we do that? Now, we can create a transfer. We can create a variable of transfer. We're going to call it transfer like so. Then it's going to be of what data type? Would it be string? No. Right? It would be of, the transfer would be of data type transfer, right? It would be of data type transfer. So it would be of data type transfer, like so, right? Now, we're going to use a keyword that we've never used, and I'm going to explain it. So I'm going to say storage, then I'm going to do is equal to transfer, right? We want to check now in this scenario, we want to check if the transfer exists, right? So we're creating a variable of transfer of this type transfer, right? Now remember we created this data type in a struct. Then we're saying we're checking the transfers. We're checking if it matches the transfer ID. So my question is, why are we getting this error? Expected transfer. Why are we getting this error? Storage transfer is equal to transfers. We're having an error somewhere. Let me check. Transfer claimed. Past error, secret label, got identifier. Oh, storage. My storage spelling was wrong. Storage. And so we have it like so. It's telling me that I can make this function a view function. We're not done writing the function, so ignore this. It's telling me that I can just make the function a view function. Right? But we want to claim, it's not going to be a view function. We want to claim. So the first step is to actually get the transfer. Right? Then I'm going to explain what the storage keyword is. So what we are doing is we're creating a transfer variable here. Then we're setting that transfer variable to be equal to the transfers, this mapping that matches the ID that the person is calling, right? So we're checking the ID to see if it matches what this person is calling here. So we are setting this particular transfer variable to be equal to the mapping that matches the transfer ID that the person passes when he calls the claim transfer, right? So we're saying that this transfer variable is equal to the mapping, because this transfers that we have here is a mapping, right? This is a mapping. So we're saying that this transfer is equal to the transfer at that particular uint256 that the user passes here as a parameter. I hope that is clear. So we want to verify if it is okay. Now, the first step is we want to check that does this transfer exist, right? That's the first step. Remember we said does the transfer exist? So how do we check if the transfer exists? What do you think we can do? We can require that we can easily use the amount to enforce. We can do if transfer, that is this particular transfer dot amount is greater than 0, it means it exists. But if it is not greater than 0, we can say transfer does not exist. Right? We can use this to check. Right? Then we can also check. Let's check. This one is to check if the transfer exists. If the transfer exists. We can also check. What can we also check? If the transfer exists, we can also check if it has not already been claimed, right? So if it has not been claimed, what do you think we can do? How do we work around this? We can do, remember that our transfer function here, our transfer struct has a boolean of claim, which is either true or false. So we can use it here. We can do require, right? We can do require that transfer dot claimed, right, is true. That's what the statement means. If transfer dot require, that is, if not, what we're doing here is we're checking if it is not already claimed, right? So this exclamation means that if you remember that we set transfer to be false. So if claimed is not true, right? That is what the statement means. If claimed is not true, right? We're now saying that if claimed is not true, everything is okay. But if claimed is true, we are saying already claimed. I hope you understand what that logic is. So what this is simply checking is if claimed is not true, right? Because it's a boolean. Everything should work well. But if claimed is true, revert with this error that's already claimed, right? Then we can also check also if the caller, that is the message or sender, is the intended recipient. Intended recipient, right? So we can do transfer. Remember that transfer. What can we now do? We have what? Message or sender. You can say message or sender is equal to transfer the recipient. Remember that this transfer struct has type of recipient, right? Has a data variable of recipient. So every of this transfer, what we're using here is this transfer that we declared here, the transfer that we get, right? So we're getting the transfer, right, that matches the particular ID that the person is calling in the claim transfer. Hope that is clear. So we are now using it to tap into all of this. This should just be 2 equal to. So we're checking if the message or sender is equal to transfer the recipient. So something is wrong with my logic here. This should be require like so, and all of that. Then what do we also have to check? We're doing quite a number of checks. We're also checking if the deadline. So I think I'm just going to leave the comments. I'm just going to say if the deadline is not passed. So I'm just going to do block the timestamp, timestamp is less than transfer the deadline. We want to write deadline passed. All that check, dude. I'm tired of the checks. Block timestamp. I'm tired of the checks, sincerely. So we also want to check for the password, right? Now, please pay attention here. How do we check for the password? Remember that we said that bytes 32 is what we use in like handling of hashing, things that are related to password hashing, keysack, blah, blah, blah. So we can say if the input hash, we create a variable of byte 32 and call it input hash, right? Then we now say keysack 256 ABI encode packed ABI.encode packed. What am I typing? ABI.encode packed, right? Like so, it takes the argument of password, right? Now we've created this like so. what we can now do is enforce the check. You remember that when the user created the transfer, they passed in a password, right? And we hashed it in here as the hash password. This is where we hashed it. We encoded it. Then this ABI encode pack converted it to a byte. Then that was what hashed it, right? So what we want to do is that what's the password that this user is passing in the claim transfer, we're also hashing it too, right? But what we are now doing is that we are now going to check. Remember that the password here is stored as a hash password in that mapping, right? So when the user created the transfer, he created the password, right? And we hashed the password for the user in that mapping, right? Now, also in this transfer, whenever another user the recipient wants to claim the transfer, he puts in a password, we hash the password. Remember, this is what we did here. We hashed the password. Then we're now going to use a require to enforce that what the sender did put in as the password is the same thing that the recipient to put in as the password. And that's what we're doing now. So we're going to say if the input hash, we can see if the input hash is equal to the transfer dot what password hash, everything should be okay. But if it is not, we will now do incorrect password. This is a lot of checks. Yeah. So if all of these do go through, what we can do is we can now update the state before sending money. And it's very, very important. That's what we call reentrancy attack in Solidity. And we're going to talk about, I hope that we'll talk about it, but you can actually read about the reentrancy attack. So we have to, the next step would be to update the state. It's very, very important. After you make a transfer, that is not when you should update the state. You should always update the state before sending the money. And it's very, very important. So what we can do here, we can do transfer.claimed is equal to true, like so, because it was set at false in this create transfer function. So we're going to set it to true, right? Then also we're going to set the uint 256 amount to be, we're going to call this amount to be transferred or amount. Very important. You're going to see why we do this, why we did this. Then also in sending the money now remember that we've set the claim to be true. We created a state variable of amount and we set it to be equal to transfer the amount. Now, the next logic would be to actually send the ETH to the recipient, that is the person that is calling this claim transfer. So how do we do that? We use the keyword payable, right? Then we pass in transfer the recipient, right? Then we'll do transfer, then we pass in the amount. Now, in doing this, why we're using this transfer is because we just want to spend a normal ETH transfer. If I am correct, we just spend 2,100 in gas, but there are complex logic that we might get to spend more than this. And that is why some people would use the call approach. And while this approach is much more secure, in this particular scenario, let's just stick with the transfer method because we're just transferring ETH, right? But in more complex logic, you can use the call method in making transfers, and you can just do like little research about it, right? What's the difference between the transfer method and the call method, right? We can ask the AI, what is the difference in call and transfer method when sending transactions? So let's see what it says. So you can actually just read about this, right? So it says that it's recommended for simple ETH, and see that the transfer method is actually recommended to when you're sending simple ETH, and the gas limit is fixed gas 2,300. I thought it was 2,100. Then for the call, flexible but risky, if all the remaining gases are set, dangerous, recipients can call. So they said it's prone to reentrancy attack and all of that. Then it's less gas efficient. When to use, sending to smart contract, when you need to undo features, when you need to check if the transfer succeeded, alternative to call. You can just make your finds about this, but in more complex logic, you might want to use the call method, but because we're just transferring ETH, we just want to stick with this approach, right? So we use the payable keyword, we pass in the recipient, transfer the recipient, and the transfer and the amount that we want to send, which is what we've declared here, right? Now, the next step will be for us to emit an event that we just sent money, and it's important, right? So how do we emit an event? We can do emit, transfer claimed, right? I remember this takes in three things: the transfer ID, the recipient, and the amount. So the transfer ID will be the transfer ID that the user passes as the param. Then also the recipient will be the transfer, the recipient. Then the amount would be the amount, right? So with this, we've actually written the code to actually claim a transfer. We've written the code to claim a transfer. Now, I'm just going to write I'm going to copy this. I want to just write, if the duration is still valid, if the duration is still valid, right? Then also, if the password is correct, right? If the password matches, is correct, then we update states before transfer. Very important. We update states before transfer. Then this logic in itself is how we transfer ETH. So after this, we emit an event, and it's very important that you actually update the state before. You do not pass all of this after you have updated states. It's a very bad approach, and our code might be susceptible to a reentrant attack if a malicious attacker maneuvers this away, right? So with this, we've actually created the claim transfer function, and I hope it is clear. Remember that, yes, and there's one thing I mentioned. I mentioned that we use the keyword that we've not used. Now we use the keyword storage. Notice that you've not seen this keyword thrown around. So the storage is a direct reference to the blockchain storage, right? And it can be modified. But memory is temporary. It's a temporary storage, and the modifications that we make will not get saved. But I declared this as storage. When we use storage because we need to modify the claimed field, right? But this memory is a temporary copy, and the modifications that we make will not reflect in our contract. But I use the keyword storage here because it directly gets stored in the blockchain, our contract storage, and because we would need to modify it, that is the variable claimed to true, I declared it as storage. So that was why I used the storage keyword, right? Now, we check if the transfer exists by doing this, right? We also check if it has been claimed and all of that stuff. Now, this mapping is this was how we got the transfer. So whenever the user is calling the claim transfer, we're expecting them to pass the ID of that transfer, right? And if it does match and all of these fields go through, it will now, if the password is correct, if the claim is true, if the claim is not true, if the claim is still false, and the message of sender is the person that we expect to be the recipient, we can then now proceed to transfer. We can then proceed to transfer the funds. Now, if you notice, we updated this state. I'm revisiting this. This update state here before we make the transfer is very, very it's a very important practice, and when it is not done well, it can cause critical security issues. Now, why we mark the claim before the sending ETH is, imagine this, that an attacker calls claim, right? An attacker calls claim. We send the ETH, the attacker contract receives the ETH, then the attacker contract now calls again. He calls this function one more time. That is what we call re-entrance. It's to re-enter, right? So when the person is calling this function again, remember that we would have not called claim. We would have not marked claim to yet, so it will still work. So the attacker has the possibility of getting the ETH twice. But if you do this before the transfer, there's no way that this particular logic will go through. This particular check of the require will go through. That is why we have to mark claim first. And you can read more about reentrancy attack. And we emit an event that helps us create a log and in our blockchain. So now let's build the refund transfer functionality. Now, this refund functionality helps us to undo refunds. So if the recipient does not claim by the deadline, the sender should get their ETH back, right? So the logic is similar to the claiming, but with different checks, right? It's similar to the claiming, but with different checks. So how do you think we can work around this? Let's think about it. Let's think about it. So also, like we always do, let's create an event again. Yeah, and let's call the event. I'm just going to copy transfer claimed here. I'm going to paste it here. Let's call it transfer refunded. Transfer refund. Should I call it refunded? Let me call it transfer refunded. I'm going to say it's going to have transfer ID, but in this situation, it should be sender, because it's the sender that wants a refund, then the amount. Now, let's come down here. We have this refund transfer. What are we expecting? Also, we'll be expecting a transfer ID. So when the user wants the refund, we want to know the transfer ID, right? That is, what's the transfer ID that you used when you made the transfer? Very important. Then we also want to get the transfer. I can just copy this. Yeah, like so. Remember that we're using storage because we want to edit it, right? So we're using storage here like so, like we did here. Then we get the transfer, right? So we have to run our check. We have to check, does the transfer exist, right? Has it been claimed? And all of that stuff. So I can just copy this. In situation, you understand, imagine that the sender wants to claim what has already been claimed by the receiver. So why do you want to be like that? We're not going to allow you. So we're going to enforce all of this, right? Require that it is not already claimed. Then we also check if the person that is calling it is the sender. So is the caller the sender? That is, you that you want a refund, are you the one that actually sent it at first, right? So we can do require. We can say if the message the sender is equal to do the equal to use to of the transfer the sender, right? Then you can say not the sender. So if this is false, this would trigger. So not the sender, then semicolon. Then what do you want? So we want to check if the deadline has passed. As the deadline passed. So what we'll do is we're going to check if. Now, how do we undo this? When the person wants a refund, you cannot, as the sender, you cannot trigger a refund if the deadline is still available, right? If the deadline is not passed. That is how we're going to work around it. So we can do require, right? We can do block the timestamp, checks the current timestamp. If it is greater or equal to the transfer deadline, right? We want to say the deadline has not passed. The deadline has not passed yet. Please let the recipient get his money. All these checks are very important. So you understand what this is, right? So if the timestamp is still greater than the deadline, the person should not be able to trigger a refund. Now, we now also have to update state 2, right? So transfer.claim, before sending the money, you can do transfer.claimed, right, is equal to transfer.claimed is equal to true. We said transfer.claimed is equal to true, right? Then we can now also create a uint56, say amount is equal to message.value, right? To get the message.value, then we can now send the ETH back to the sender. So how do we do that? We do payable. Remember how we did the first one? Transfer, passing the address of the person that is meant to receive it, which is the transfer.sender, right? Dot transfer. Then we also do amount. So why am I getting this error? Okay, this message transfer amount is equals to method value. Method value and core value can only be used in payable function. Okay, so we have to declare this function to be payable, which I did not do, right? Then we can emit an event, just going to say emit transfer claim, transfer refunded, right? Then it takes in the transfer ID like so. It takes in transfer dot sender and the amount. So with this, it's quite simple and less complex than the claim transfer, but we've created the refund transfer. So this function is simpler, and I'm just going to highlight the key differences. So who can call the refund transfer, right? So the person who can call the claim transfer is the recipient. Only the recipient should be able to call the claim transfer, right? Now, the refund, only the sender should be able to call transfer. Now, in the deadline, the claim deadline, if the block timestamp is less than the transfer deadline, the person should be able to call. It is only when it is greater than that we should say the deadline is passed. Then also for the refund should only be possible if the deadline is passed, if the current time is past the deadline. That is when the sender should be able to call the refund function. And in the refund, we do not require a password. The sender does not need a password to actually get their own money back, right? And we also have to ensure that we update the state before we send. Very, very important to prevent reentrancy attack, right? Then we've come so far, right? We've learned about struct once again. We've implemented the claim transfer. We've also implemented the refund transfer, right? Now, we have to now move to the process of actually scaling our contract on a real testnet, not on Remix VM, right? So let's see if everything compiles well. Compile secret.pay. We see that our code compiles well, right? And currently, the deployments that we've been making have just been on Remix VM, right? But we can proceed to actually now learn to actually deploy it on a real testnet like Sepolia and all of that stuff. Now, what we've learned in this claim transfer is that we've learned password verification, right? We learned how to verify the password in the claim transfer. We also learned how to send ETH from a contract to users, right? Using these functionalities. Then we also learned time-based condition also, right? We also implemented time-based checks in all this place. So our contract can now accept ETH with password protection. It can now verify the password securely, send ETH to recipient. We can also now undo refunds after deadline, right? So we now have to actually learn about cleaner code implementation, gas optimization practices, and also custom modifiers. So let's dive deeper into the rabbit hole. Now we're so close to having a production ready smart contract. So right now our SecretPay contract can actually create transfers. It gives users the ability to claim those transfers with passwords and also get refunds. So it's actually functional. But functional and professional are different things. So we're going to further take this deeper by making our contracts more production ready. We're going to have things like modifiers, better security patterns, and all of that. So what we want to do at this moment is to ensure that our code is cleaner, more secure, more efficient, and more professional, right? So let's level up. Now, the first thing that we have to do is to test our functionality and see that everything works just as they should, right? Now, what we can do is we have our code here. We can actually compile secretpay.sol, and we have this green check mark, which means that it is compiling well. Then we can proceed to deploy it on Remix VM virtual machine. So we can just click on deploy. Okay, so that goes through, right? So we have that this transaction goes through, and now we can see that SecretPay is displayed down here. So if we click on it, we can see that the transfer count is currently 0, and we initialize that in the constructor, right? We initialize the transfer count to be 0, right? So the transfer count is 0. You can see that the claim transfer payable functions, the claim transfer is not payable, and I think this is a mistake, right? Is this a mistake? It should be payable. This claim transfer should be payable. Why we did not mark it as payable, right? So let's tweak that. I'm just going to make this payable. Yes, it should be payable. Then I'm going to delete this and redeploy the contract. So compile, it's positive. We're going to click on deploy, and here we go again. Now the claim transfer, create transfer, and refer transfer are actually all payable, and that is why the color is a little bit different. If you remember when we deployed the Hello World contract, the set message was giving us this color because it was just a write function and it was not marked as payable. So I think Remix makes its payable function with this color. So let's proceed to test and see. So our transfer count should be 0 because that is how we set it in our constructor. Then we should be able to create a transfer. So it takes in a parameter of recipient, the password, and the duration, right? So we can get an address from here, from one of the accounts here. Let's get the third account. Let's just copy the address and switch back to the first account. Then let's create the transfer. The first thing it takes is an address, right? It takes an address. Then the second thing it takes is the password, right? So the password, let's use 12345. And the duration is in seconds. So let's use 60. Now there's something I want to address, and something that I've been saying. The block timestamp is not just the current time. It is the current time at which that block is mined. So transactions are mined. When we say transaction in mine, it means that the transaction has been validated on the blockchain. So the block timestamp is when a particular transaction has been mined, right? So let's say when you call the claim transfer, it's at 6:01. The block timestamp becomes 6:01, right? So it's subtle, but it's different, right? So the block timestamp is when the transaction is mined, right? It's the current time at which the transaction is mined. So just take note of that. And the duration should be, let's use 60 seconds. So if we click on create transfer, we get the transaction has been reverted. This does not work, right? We're getting this red note. And what is it saying? The transaction has been reverted to initial state. You must send ETH. Now, why are we getting this error? We're trying to call the create transfer without sending ETH. And it's a bad approach because we marked our function as payable. So how do we send ETH in Remix? Now, initially, I have tweaked this. How it's going to appear in your end will be in way. Remember that we said that the minimum, that value in Solidity is tracking, where way stands for 10 exponential 18, right? So we need to send ETH alongside this transaction for it to go. So I'm just going to, I can just send one ETH. I can do 1, 2, 3, 4, 5, 6, 7, 9, 10. That's long. I'm just going to change this unit back to Ether and send 1 Ether. Then I'll click on create transfer. So it does work now. Now it tells us that we've created this. Now, if you come to our transfers, remember that the transfers tracks the mapping, right? The transfers is a mapping, and this transfers here is a mapping, and you see that it expects an input of UN256, right? I remember that at the point of creating this transfer, our transfer count was 0. Remember that the transfer here takes in the transfer count. So it means that invariably, this particular transaction would be stored on the transfer mapping at 0, right? So if I put in 0, it's going to give me that particular transfer. You see the address of the sender, the address of the recipient, the third address here that ends with 2db. That should be the address of the recipient, 2db, right? The amount is 1. This is 1 Ether, but extracting we, right? So 1, 2, 3, 4. This is 19 decimals, right? Because we used 1 ETH, 10 exponential 18. Then the password is, you see that the password is not as in plain string, it is hashed. And the deadline is in Unix, and by default the claim is set to false. But if we hit for one, a transfer that does not exist on that transfers mapping, because we've not created any transfer on the transfer count 1. If we hit transfer, we're going to get a null address 0x0. that is nothing. By default, the claim would be false, because by default booleans are false in Solidity, I think, right? You can confirm that. Then by default, so UINTs are 0, then the recipient will be a null address. All of these are null address, and the password, so everything 0x000. So our code is working so far so good, and we've set the claim transfer to be in 1 minute. But if you know, I want you to notice something. Initially, the balance of our SecretPay was 0, but now it is 1. It means that claim transfer immediately was initiated. The funds was sent to our contract. So our contract is the one holding the fund, right? So if we are still within the 1 minute time frame, we can switch back to this third account and try to claim. Let's try to claim the transfer. The transfer ID was 0 and the password was 1, 2, 3, 4, 5, right? If you click on claim transfer, we see that the 1 minute time span is passed, and we're having an error saying the deadline passed. So the claim transfer reverted. Now, let's say another user tries to come, let's say this same user tries to come to get a refund, somebody that did not initiate the create transfer. That is, this is the third address. If the user comes here and passes the transfer ID at 0 and clicks on refund transfer, we see that it's telling us that this person is not the sender. But if we switch back to the person that initiated the create transfer and we pass in refund to be 0, I'll click on refund transfer. We see that it does go through, that the refund does go through. Now, so far so good. Our contract is functional, right? our contract is functional. So now let's proceed to understand our codes like professionals. Now, if you look at events are like notifications that will help to log specific and important things on our contract, right, or the blockchain. So with indexed events or with indexed variables or declaration, we can actually find or filter things easily. Now, without the index tag, imagine that we're dealing with a large amount of data and you want to actually filter through it with specific intention. Without this index tag, it will be hard to actually go through those data sets while filtering it. But with the index, we can search that, show me all events where the sender matches a particular declaration, right? So with this, it makes filtering data on the blockchain much more easy, right? So that is the importance of indexing certain things in an event. And there's a particular rule whereby you can have up to 3 indexed parameter per event, just up to 3, right? Now, there are some other approach that we must also consider, right? Now, other approaches that we must consider is how to actually view events. Now, we would look into all of this as we move to the likes of Etherscan and all of that, or a testnet on Etherscan, hosted on Etherscan. I would have loved to show you here on Remix. Whenever you mine in transaction, you're going to see it actually that an event was emitted, but it's not necessary. So that is that about that. But events are very important as we proceed. Now let's talk about custom modifiers. And this is to the end that we want to actually remodify our code like professionals, right? Now, if we look at our claim transfer function, we see that it has quite a number of require statements, like require that the transfer is greater than, require that claimed, require that method of sender, quite a number of them. And it makes our code much more bulky, right? And if you look at our refund transfer, we have quite a number of require. There's a lot of repetition. Now, for instance, if you look at this refund transfer and a claim transfer, you would see that they both require that the transfer exists, right? And they also both require if it is already claimed. So this particular approach, or the particular way that we wrote this code logic, it evaluates the drive principle in programming, right? There's what we call the DRY. It means don't repeat yourself. But modifiers solves all of this. So they are like reusable security guards for our function. So let's create a modifier. Now, to use a modifier, we can just use the keyword modifier like so. Then since these two functions checks for transfer and claim, required transfer, both in the refund and claim, we can just create a modifier that checks if the transfer exists. And how do we do it? We can do modifier by using the modifier keyword transfer exists, then use unt256, right? It takes in what the transfer ID to, then just insert transfer ID like so, then transfer ID, then we're going to just do require, then we're going to require that the transfers, right, that matches that mapping on this particular ID, right, on this particular ID, the amount is greater than 0. Then if it is not greater than 0, we want to say transfer does not exist. Transfer does not exist. Right, then this would have this like so. Then also we're going to end the modifier with this syntax, and you're going to understand what this is. Now, what we're doing here is that we're checking if the transfer exists. This modifier is taking a parameter of transfer ID, right? So from the transfer mapping, this mapping data type, this mapping variable, we are checking the particular ID of that transfer to see if the amount of that transfer is greater than 0. And if it is not, we're reverting with this error, transfer does not exist. I'm going to explain what this syntax means. Now let's also create another modifier. I'm going to copy this and just call it already claimed, because these are the two required statements that are similar in the claim transfer and refund transfer. We're checking if the transfer exists and we're checking if it's already been claimed. So let's create a modifier so we can make our code base cleaner, right? So it takes in a uint 256 of transfer ID. Then what we're going to do is we're just going to check if claimed, then this would be like so, right? Like so, then this is no amount, then we say transfer already claimed, right? Transfer already claimed. Now we have our transfer modifier. What other modifier can we implement? Now, we can, for the claim transfer, we can create a only sender, or for the refund transfer, we can create a only sender modifier, right? So a modifier that will trigger only something that is associated to only the sender, right? So we can say only sender. You're going to see why this is very important. We can say you're in 256, then do transfer ID, right? Then we can also do require, I should just copy all of this for the sake of time. Then paste this here like so. You're in 256, you in 256, why? What is wrong? Trying to see why I'm having this. I think I'll just ignore that. Don't know why I'm having that particular red. Let's see, does it compile? Expect. I can't actually see the area. I know you might be seeing it, but I'm just going to copy this like so and change the name to. The arrow is looking at me, so I'm going to call this only sender. Transfer ID. Then if the sender is not equal to message of sender, you get how this is going to be, right? You say if message of sender is equal, is equal to the sender, right? Sender, then we would say not the sender, not the sender. Then we can have the same too for only recipient, right? We're going to tweak it like only recipient. We're going to do, what would this be? How is this implementation going to be? If message the sender, still message the sender, the recipient, right? Recipient, we can now say not the recipient, like so. Then we can also have, can have modifier, right? We can also have modifier before deadline, right? I'm just going to copy all of these for the sake of time too and paste it in front. Then I'm going to do it like so. Then how do you think we're going to work around this? We're going to use the block timestamp, right? So we're going to say if the block timestamp is less than the transfer ID, right? Deadline, like so. Then this should work. So we could also have after deadline and let's just do the after deadline. So what would this be? This would be what? Greater than and equal to. So it will be greater than equal to. So these modifiers, this transfer exists modifier checks if the transfer does exist. That is, if the amount is greater than 0, it means that the transfer does exist. The already claimed checks if it has not been claimed and all of that. So the next step is, how do we use it? So the modifier keyword is obviously ensuring that whoever comes after this is a modifier. Then the underscore, yes, this underscore that we have here is a special syntax. It simply means that run the function code here. So this is how it works. So the execution order would be that it checks the modifier conditions. If the pass runs, that is, if everything runs, then run the other things that exist in the function. But if it fails, do not run every other thing in the function. And I'm going to explain. Now, this underscore here means that run the function code here. So when we take, let's say we take this transfer exists. Let's take this transfer. I think my explanation might not make you understand. Let's say we take the transfer exists function, right? And we go to the claim transfer, right? We're going to use that transfer exist modifier in the claim transfer function. How? To use it in the claim transfer function, we can just do transfer. Let me just paste it here. Transfer exist. I remember that it takes what? A parameter of what? Transfer ID. Right? It takes a parameter of transfer ID. So by saying this, we are simply telling our claim transfer to check if the transfer exists, and we can simply comment this out. Why? Because we've passed in this modifier, right? You see that it's a much more better way to write this. Now, also in our refund transfer that checks if the transfer exists, rather than also doing it, we can just comment it out. Then, because the modifier gives us easy reusability, we can just pass in transfer ID like so. So it makes sure the modifier helps us to enforce that our code is cleaner, and rather than having to redeclare redundant require statement, we can just do it once and for all. So to further drive the point home, what I'm trying to say is that this underscore can come in two ways. It could come above here like so, or it could just be below it. So when it is below it, we're saying that before everything here triggers, check through this modifier. Then if it is successful, run everything below it. But assuming this underscore was just above it, it means that run everything here at first, then check if the modifier goes through. I hope that sticks, right? So that is why that underscore is very, very important. So this is the basic implementations of the modifier here in our claim transfer. Also, we can also use the not claimed, right? Then we can, it takes in transfer ID to like so. It's not claimed, already claimed. I'm just going to call, let me change this to not claimed, so that should fix the error. Yes, so we can actually have, you can easily use, and also I can just pass it here, so then I can comment this out and do not claimed, and I'll pass transfer ID like so. So modifiers are very important, and they help us to actually approach our code in a cleaner and more nice formatted way, right? So you can see how cleaner it gets. You can actually tweak it to, we have quite a number of them, only recipients. You can attach it to where, like, the only recipient should be in the claim transfer, because it should be the recipient that should be really able to call the claim transfer, right? And is there any other thing that I would love to cover, right? So far so good. As touching security, reentrancy attack, why this is very important is that the flow of payable functions, we must pay attention to it. And I just want to emphasize this once again. We've seen quite a number of hacks in the cryptocurrency space. Like in 2016, there was a decentralized autonomous organization hack. I think around $60 million was stolen due to using reentrancy attack. And I think that was what led to Ethereum hard fork. So that was like the biggest, if I'm correct, that was like the biggest hack in the crypto history. So that's very scary. And you might say, I'm just writing this small contract. You know, over time you're going to get gain mastery and start writing more complex code and all of that. You can land jobs in the likes of Uniswap, Eve, and you're told to actually write contract and carry out tests. So these implementations, the ability to actually be committed in little things would actually influence how you're going to manage much more complex code logics. So it's important that before you call a payable function, you always update the state of variables that are critical to ensuring that a transaction has been triggered. So for instance, let's say we call the payable here, right? And we pass in the claim to be false. And let's say we even still leave amount here. And obviously you might think this code logic is okay. But once this payable is triggered, once a malicious attacker sees this loophole, they can enter this function without claim being updated to true, right? It means that they can actually send, they can trigger multiple withdrawals, because our code here is actually requiring that claimed is not true, right? Then if you're actually withdrawing funds before you update the state of claim, it means claim would still be false and a malicious attacker would be able to actually perform reentrancy attack on our code. So aside writing a very fine and well formatted code, we want to ensure that we actually adhere to good security practices, and you can always get better and better. You know, this is just like an introductory tutorial. Make sure that you enforce things using the require keyword. We could also create custom errors, but I would not want to cover that in this tutorial, right? So we can actually dive into, there's a lot of things, access controls, using modifiers, input validation, and even this our logic uses deadline enforcement. You can do all of this with the modifiers that we declared here before deadline and after deadline. So that is that for that, right? So the next step that I would want to consider is how we can, there are other things. I would leave this to you as a take home: gas optimization, how you can actually optimize gas better. But currently, if you notice, once we refresh on Remix, let's say we've made some deployment and all of that, everything gets lost. So I would want to take you down to your local machine, how you can implement this in your local machine, right? And how you can actually deploy it to a testnet like Sepolia.etherscan.io, right? And all of that. So that being said, you've had an idea about how professional grade contracts should be written, how to actually write well documented and industry standard code bases, right? So this is a good and solid foundation for you, right? And I'm giving you a nice congratulations for coming this far. So that being said, let's take it down to VS Code, right? Then teach you how you can actually make deployment to a testnet like Sepolia and set up wallets providers like MetaMask, get a testnet ETH from ETH Faucet to deploy your token on a testnet, and so you can share your contract with your friends. So let's go into that. So now let's look into how professional blockchain developers handle deployment, work with version control systems like Git and all, and how they follow a industry standard, right? So we've learned how to compile our code on Remix, write our code on Remix, and deploy it on Remix virtual machines, right? So now let's use the professional approach. So we'll be needing certain tools. We'll be needing VS Code. So VS Code is an IDE, it's a code editor whereby we get to write code effectively and much more intuitively, gives us a nice UI. Then also we'll be needing a tool called Foundry. So Foundry is a fast development framework for Solidity. Is very fast and efficient. And also in VS Code comes with a functionality, a terminal functionality, whereby we can actually deploy and verify straight from the command line. And this is how real blockchain developers or experienced blockchain developers do it in companies. So this is important because it's actually it's the industry standard first, then it enables better and efficient testing, faster testing, and it gives us the ability to work with version control tools like Git. So I'm excited to show you how to effect this exact deployment just like we did on Remix, but like a pro. And don't worry, I'm going to walk you through every step, even if you've never used the terminal before. So let's level up. Firstly, we need to install VS Code. Now, to install VS Code, we can simply search on our browser, install VS Code, like so. Then you can click on the first link. So depending on your local machine, if you're on Windows, you can click on the Windows icon. Then if you're on Mac, you can click on Mac. So I do already have VS Code installed in my personal computer. So I've opened a folder, a directory in VS Code, and I named it SecretPay. So in this remix version, I created the contracts folder. All of this code will be available on the GitHub repo attached in the video description. Then also, you can ignore these dependencies. I just tried to mimic something similar like we had in Remix, the dependencies, folder, states, and artifacts. You can just ignore it. But the major focus is the hello-world.so that we learned, my name, and the secretpay.so. So what I did was that I just copied all of the code base that we had in Remix and I pasted it in here. So the next step, what we have to do now, once you've installed VS Code, the next thing you have to do is to install Foundry. And the Google search will do, you can just search Foundry installation, like so, then hit enter. Then we can click on the first one too. So it tells us installation, blah, blah, precompiled binary, use Foundry, or Foundry Up is the official installer for the Foundry chain. You can learn more. So to install Foundry Up, open up your terminal and run the following command. So to install Foundry, we can just copy this code. Then, now I want to say something. Because I'm on Mac, it's quite easy, right? I can just copy this and run it straight in the terminal. But if you're on Windows, you need to, the option that I would recommend, you can also Google search how to install Foundry on, I think you're going to need WSL. I'm not saying for sure, but also in the code base, I'm going to attach a TXT file or a README on how to install Foundry on Windows easily. I'm going to install that, so you can just check it through also. So we're just going to copy this link. Then in the terminal, we're going to just open the terminal. Now to open the terminal, you can easily hit Control and backtick. So backtick is the key on your keyboard before number one. So once you hit Control and backtick, you can just easily paste that here, then hit enter. So this should actually install Foundry. So it says Lips, you may need to install it manually on macOS Homebrew. You can just ignore this. Then it tells us that run source. Okay, you can ignore this. This is then simply run Foundry up to install Foundry. So if I copy this, yeah, like so, if I just run Foundry up, so that's now Foundry Up. What Foundry Up does is that it installs certain things for us. So Foundry, by running Foundry Up, I mean to say Foundry comes alongside with Forge, like you can see here. It gives us the ability to use Forge. I'm going to explain what they do. It gives us the ability to use Forge, the ability to use Cast, to use Anvil and Chisel. So what is Forge? Now, Forge is a tool that comes with Foundry that we can use to compile, test, and deploy contracts. And the Cast, like you can see here, gives us the ability to interact with already deployed contracts. Then Anvil, ANVIL, is a local test blockchain whereby we can use to simulate things. Then also the chisel that you see is it's more like it gives us the ability to test Solidity snippet codes. Yes. And we're going to use them in this particular section. So you're going to understand everything. So just in case, if you get stuck during the installation, it's actually normal. Just make sure you check the error message, you Google it. There's a lot of things on Ethereum Stack Overflow, documentation that are there to help. But I'll make sure that for Windows, I'm going to install like a process on the code repo in this description, in this video description. When you check the repo, you would see how to navigate it on Windows. Now, what we have to do is that we have to now proceed to create a proper project structure. And I would not lie, sometimes installation, especially on Windows, can be the hardest part, but once it is installed, everything else gets smooth. So now what we have to do is to create a professional project structure. So what I did in this SecretPay, I created a Remix version, like I said earlier, where you can see everything similar like we did in Remix. So now what we can do is, there are two means to actually create a folder. If you're new to VS Code, you can easily click on this icon here. Once you click on this icon, so if you click on this icon and it's currently showing on this, the folder will be created in this Remix version. So this is highlighted and you click on the folder icon, it's going to be created inside Remix, but we don't want that. We want it to be outside the Remix version. So I'm going to click here, just outside all of this. And this is what I call the root directory. This is what is called the root directory. Then if you click on this, then write Foundry, it's going to create a Foundry folder inside the SecretPay folder, not inside the Remix version folder. But I'm going to show you how to do this also with terminal. I'm just going to delete this, right? So in this terminal here, what I can do is I'm just going to write the command in my terminal, mkdir, which means make directory. Directory is the same thing as folder, and I do Foundry. This will create a new Foundry folder here like so. Then also, the next step will now be to actually initialize Foundry. So if you currently click on this Foundry folder, you'll see that it is empty. So we have to initialize Foundry. We have to create a proper structure for that Foundry, for our Foundry project, right? Now, Foundry is a much more better way to actually compile, test, build, and interact with already deployed contracts, unlike Remix. I remember that we said that the issue with Remix is that anytime you refresh, you lose every of your deployed details. So we need to be inside this Foundry folder to actually do things. So because we want to initialize Foundry inside the Foundry folder, we have to enter into the Foundry folder. And to do that, we usually use the command cd, it says go into Foundry. So we just type Foundry. Then if you hit the tab folder, it automatically suggests autocomplete the spelling, then hit enter. So right now you can see that it has changed from SecretPay to actually Foundry. So right now we're in Foundry. Now the next step to do is we have to now initialize Foundry. Now to initialize Foundry, we simply it's available in the documentation, you can confirm online, you can just do forge init. So this command in particular initializes everything. So when we click on Foundry, once we've initialized it, you're going to see quite a number of already defined templates. So if you hit enter here like so, you see quite a number of things. I will see that we have .github, libraries, script, source, and the test. Now we're going to understand everything that the project actually contains. Now, if you click on this source, the source is where the contracts themselves are stored. The test is where test code bases are stored. The script is where we write various scripts. So we do not need any of this. So the first step will be to delete. We can delete the counter.so here. We can also delete every of the counter.so. These are just dummy codes. Then what we want to do now is we now want to move the code that we have in Remix to this professional Foundry structure, right? Now, to do that, we can just, since I already copied it here, I can just click on contract and click on SecretPay.so, Ctrl A, Ctrl C to copy, Ctrl A is to highlight all, then Ctrl C is to copy. Then if I come into the SRC folder and I'll click on this file to create a new file, I'm just going to click on this. Then I'm going to say SecretPay.so, then I'll hit enter. So I'm going to paste it here like so. So this is the entire code base. Now, if you look at Foundry, Foundry gives us a more professional folder, a more organized folder structure, and it also gives us the ability to interact with Git. So Git is a version control system and gives us the ability to actually even write scripts, that is automated deployment scripts, and it gives us the ability to carry out professional testing. That's why you see the test folder. So what we can do now is now try to compile our code base since we've already initialized Foundry. So the next step that we have to do is to compile our code base. So how do we do that? Now, to compile a code, we can simply run forge build. So inside our terminal here, we can just do forge build. So we're going to see, in Remix, to compile a code, we just click here, click on this, compile SecretPay. So if it's successful, we see this green check mark. But in Foundry, we can just do forge build, then we hit enter. So we're having some errors. And what are those errors? So let's check. Now, what we're having now, if you notice, we did not get any error on Remix. Everything compiled successfully. And now this is where the concept of being a developer comes in. But here in Foundry, we did get an error. We're saying that the use of inefficient hashing mechanism, consider using inline assembly, blah, 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 the KSAC 256, we're having a linting error. This is more of Solidity linting error. Foundry linting error, not a Solidity issue. The code base is okay, but because of the way Foundry is structured, Foundry emphasizes a much more cleaner code approach, right? So this is the advantage. This is one of the advantage of working with Foundry. So let's try and debug this. So let's put on our debug glasses together, and let's see what we're having. This actually saying that we're using inefficient hashing mechanisms, that we should consider using inline assembly. So it also, if you notice, it gives us a link to check all of this. So HTTP book. So if we click on Get Foundry, so if I open, so it's telling us, if we click on that link by just simply pressing command and this, we're going to see that particular link open. Command and tap. So let's see what the error is saying. It's saying that gas optimization, it recommends that we use inline assembly for KSAC 256 hashing when possible. The Solidity global function KSAC involves memory allocation and copying, which can be less gas efficient. That approach is not really gas efficient than a directly inline assembly implementation that operates on memory directly. For production use, consider using vectorize, okay, and all of these details. Now, it's telling us to actually use an assembly implementation. So this is a sample of how we can work around this. But for the sake of this tutorial, I'm just going to disable this linting error. I really do not want to go into assembly at the moment, right? So to disable this error, we can just copy this linked documentation here and attach it in our foundry.coml file, right? So let's just copy this for the sake of time, right? And I'm just going to my foundry.coml. I'm just going to paste it here like so. Like so. Okay, so this would actually ensure that we this error is not actually treated. So it's a linting error. It's just Foundry trying to emphasize cleaner and better structure. So let's run Foundry build, a forge build again and see. So we see that the compile was successful. That is, we do not have an error. So everything worked just fine. Now, was this everything we copied? What about the, we had some modifiers, right? We talked about modifiers. So why is the modifier? Did I not copy everything? I did not copy everything. Because the modifiers are not there again. So I'm just going to, oh, I think I had not updated this remix version. I will do that. I had not updated it here. Okay, so I'm just going to update in this place. So we'll have the modifiers here like so. Then I'm going to do forge build again to see if we do not have any error. So everything works just as it should. So our code base is okay. Now, just in case on your end, you come in contact with any error. Let's say Foundry is telling you that let's use a better approach. Do not, how do I say it? Like on your end, maybe you're getting a modifier error that maybe you should declare the modifier to be internal and all of that. Just make sure that when you get that error in the terminal, you would see a link attached. Click on that link, then you're going to see how to exclude that particular error. So it's not that Solidity code I wrote is bad. No, Foundry is just telling us to use a much more better implementation. But since this is an introductory tutorial, we just want to like stay on the fundamentals and not dive into much more complex topics. But as you dive into the world of Web3, of blockchain development, I mean to say, you're going to understand how to walk around all of this. Now, so since our build is successful, what do you think? What is the next thing that we have to do? Our compilation was successful. The next thing that we have to do now is to try to verify our contract. Right? So Foundry is much more faster. Or rather, before verifying the contract, we have to have deployed it, I mean to say. So the next step that we have to do is to actually create our deployment script. Now, how do we create our deployment script? Think about it. Where would the deployment script be in? The deployment script has to be in the script folder. So we can just create a file called deployment.s.sol, or you can name it whatever you deem fit. So we can just say, call this new, then do deployment. Let's say deployment.s, which means script.sol. So we can have this like so to deploy our file, or we can just call it deploy.s.so, then hit enter. So we now have to like write the deployment. So like every Solidity code, remember that in Remix, we said that when you want to start to write the Solidity code, the first thing that you have to do is you have to declare the license identifier, which means that this code base that you're seeing is open source and it's free to use, right? So I'm just going to come back to our contract section here, then copy what we have here like so, including the version of Solidity that we're using. Then I'm going to paste it here. This is always the first thing that you have to do. But now we're in VS Code, right? Now, we have to write the deploy script, and I'm going to explain what everything does. So the first step will be to import a functionality that comes with Foundry itself, and that is the forge std. We're going to explain what this is. So we have to import forge std, then script or so, like this. This is the first step, right? Then once we've imported this forge std and script.so, we also now have to import our contract. Now, this is the contract that we have here is in our SRC. So we're going to easily do import, then dot slash, depending on where it is /. So it has to be dot slash, then SRC, right, / SecretPay .so. So what this is simply doing is we're looking for where the directory of where the SecretPay contract that we have is. So it's not, assuming the SecretPay was in the script folder, we'll just do /. But because it is outside the script folder, I have to do /. Right? And this is, if you should click on this, you should take us to where the SecretPay SRC is. So if you hit command and you click on this, you're going to see this. If you also hit old command and click on script, so you're going to see the package for the script.so, but we're not diving into that for now, right? And I'm going to explain what the script.so does. Now, the next step will be to create a contract, a deployment script contract. So we're going to call it contract. Remember, to create a contract, you just have to use the keyword contract. Right? Contract. Now, you might be asking where we got this forge std from. If you notice, you can see this folder called lib/forge std. Then this forge std, if you click on it, it comes with quite a number of things, and that is where we got the script from. But I'm going to explain what it does. So we want to create a contract that would use to deploy our contract. So we are creating a deployment contract, a deployment script contract. So what we can do now is we will now do deploy script. We're going to call this contract deploy script. Then we're going to say is script. So what this is doing here is this deploy script contract is inheriting the script functionality. That is what it's doing, right? Then we can now create a function here in our contract. That function, we can call it run. So we're going to call it function, then run, then say external. Now, I know that you're saying, what is external? You understand that this is the name of the function, but you've never seen what this keyword external is, right? I'm very sure that you've not seen what this keyword external is. Now, I think I just have to go through the explanation as you're writing the code, so you're not going to be lost and just be writing code alongside, right? So the first step is we're importing Foundry scripting tools at the very top here. That's the first thing that we're doing. And the second one, what we're doing here is we're importing the contract that we've written ourselves, which is SecretPay. So now, this Foundry script also comes with quite a number of functionality. So if you press Control on Windows but on Mac, if you press Command and tap on it, you're going to see quite a number of things. It comes with the console, VM, script base, quite a number of functionalities, right? So this script inherits other things. So here you're saying that the abstract contract script is inheriting script base, the STD chains, utils, and all of that. But we do not want to go into all of these technicalities now. So the first step is that we imported Foundry scripting tool. The second step was that we imported our contract, right? Now, this contract that you see here is the deployment script. So it inherits from the script tools, these Foundry scripting tools that we have here. Now, the next step that we have to do is that we have to create a run function. Now, this run function is what we're going to use to initiate our deployment. That's what we're going to use to initiate our deployment. And this function is going to be external. Now, we have different function labelers. Let me use that word. Permit me to use that word. Now, we have external, we have internal, we have public functions, we have internal, we have private functions. Now, external function are functions that can be called by externally owned address. So let's say functions that cannot be triggered by the contract itself. That is what an external function is. So other people, externally owned addresses can be the ones to trigger the function, right? So that is why you're seeing this keyword. Remember that in our SecretPay, so what you would have been saying is public. Now, a public function is a function that anybody can call, right? Anybody can call, but an external function is a function that only externally owned addresses can call that function. Then we have the internal and we also have the private. You can actually look up into all of this. So the next step that we have to do here is that we have to now pass in a keyword, which will be VM. We're going to use the keyword VM here. So it will be VM dot. So I think I have to recap what all of this, how this functionality will run. So to initiate a deployment, we need a wallet. So a wallet is the means whereby accounts can interact with the blockchain. So we have different kinds of wallets. We have MetaMask, we have Coinbase, we have Trust Wallet and all of that. So to make a deployment on a blockchain, on a testnet like Sepolia, on ETH Escrow, we actually need a wallet. But since we are doing everything from an IDE, we necessarily cannot be importing MetaMask key on the IDE, but we can access something called the private key. So the private key gives us the functionality to carry out transactions of a wallet. So it gives us the ability to sign transactions. So when we're deploying something to the blockchain, we actually want to initiate a transaction to the blockchain. But because we cannot access a wallet in here on the IDE, we can use the wallet private key. And to use the wallet private key, we have to store it here in VS Code. But note, whenever the private key of a wallet is given to a person, the person can do anything to that wallet. The person can steal the funds. The person can act as the owner, because anybody that has the private key is automatically the owner of the wallet. So you never want to handle or be very complacent or manage your private key poorly. You always want to manage it in a very secure manner. So we have to create a private key instance or a private key variable in our code base here. So to do that, we can actually do uint 256 like so. Then also say, we can call this function this variable private key, right? Then we can now do vm.env. So vm means virtual machine, env unit. Then we'll just say env unit. Then I'll just say private key. And I'm going to understand what this is. Now, it's telling us that unused local variable. So this can be restored to view. Because we're not done with the code base, so just ignore this error. Now, what is a .env? It begs a question. So in case you're totally new to program, you can just search what is a .env. So a .env is an environmental variable. A env file is a configuration file used primarily in software development to store environment-specific variables such as API keys, database credentials, and other sensitive configuration data. It's a plain text file containing key value pairs. So this is how we store a .env. So firstly, a .env is something that we use to store sensitive data that we do not want to be available to the public, right? So let's proceed. Now, because we're using an env, we have to create a .env in our Foundry folder. So just here in our Foundry folder, in the root directory, in our Foundry folder, we have to create a .env. So make sure that these foundries are highlighted. Just click on dot, then click on .env. Now remember that the documentation says that this .env is in key and value format, right? So, and in our deploy.script.so, right, we have the private key like so. So we're just going to create a private key variable in our .env. So I'm just going to paste this here and I'm going to say is equal to. So now the private key will be something like OX, blah, 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 but we do not have a private key. We're going to get that from a wallet. And I'm going to show you how we're going to get that. So this is what we have here like so. Now you might be asking, what does this function do? Obviously, we use this function to get the private key from the environment variable and never hard code this private key. So make sure that you never say private key is something like you'll not pass the private key like so X. It's a very, very bad thing to do. And with this, anybody that has your code can easily see what your private key is. So you always want to make sure that you store it in an environmental variable. And in fact, there are much more secure approaches than even using the environmental variable. But because this is on the foundational level, we're just going to use this env. Make sure that you never hard code your private key. Now, the next step will be to broadcast our transactions. We have to start broadcasting our transactions. And to start broadcasting the transaction, we need to use VM, right? So the VM interface allows manipulation, blah, blah, blah. So we can do VM.broadcast, right? VM.start broadcast. VM.start broadcast. So this takes a parameter of the private key. So we're going to pass in private key here like so, private key. So we're going to pass in this private key in here. Now, the next step will now be to deploy our SecretPay contract. So this starts the broadcast to ensure that the transaction gets broadcasted on the network. Then the next step would be to deploy our SecretPay contract. So to do that, we have to now create a SecretPay instance of our SecretPay contract. So to do that, we can just easily say SecretPay, which is our SecretPay contract that we imported here, right? So there are quite a number of ways to do this. So you might be confused that how are we just tapping into SecretPay? You will see some developers do something like SecretPay, the import SecretPay from. It's the same thing. So you will know that, okay, this is what SecretPay is, right? So we can do SecretPay. Then we will now create a variable that is of type SecretPay, right? So we're going to do SecretPay. So this is the difference. This is not the contract. This is in camel case. You see that the S is a small letter, but this is a capital letter. So this is our contract. Then we are creating an instance of this SecretPay. Remember that in when we're dealing with Remix, we also did something like that. In our contract, in our SecretPay.so, we created item 1 that was an instance of product struct, something like that. So that's what we're doing here, the same approach. So we're not going to do is equal to new SecretPay. Then we're going to call that function. Now you might be asking, what did we just do here? So this function here, I'm going to put a semicolon. This function here is how we create a new contract instance, right? This is how we create a new contract instance. So this function is how we deploy the contract, our SecretPay contract. Now, once this is done, the next thing we want to do is we want to stop the broadcast. So to stop the broadcast, we can just do VM you guessed right, .stop. Just like how we started stop broadcast. Then we're going to call it like so. So we're going to do vm.stop broadcast. Then we can now proceed to log the deployed contract address. So if you remember when you clicked on script, you saw console and all of that. So we can just do console.log. Then we're going to do, can just say, let me just add this text, SecretPay address, like so. Now I'm going to say the SecretPay address is address of SecretPay. The address of this contract that we initiated here. So I'm going to save this file. So why we're having that warning was because we've not used this. This was an unused variable, right? So if I log this, you're going to see that we're having like a warning here at the time that unused local variable. So by passing SecretPay in here, we've used this variable. So that warning is clear. So with this, we've simply initiated or created the deploy script file. So the first step was that we imported Foundry deployment script. We also proceeded to import our own contract. We created a contract instance that inherits the Foundry deployment script function. Then we created a function. Then the function is an external function. Then we also got the private key from the .env file. We saw what the .env file was. We started the broadcast. We instantiated. We deployed the contract. We stopped the broadcast. And we logged the address of this SecretPay, right? So we wrapped it in this address keyword. Then we passed the SecretPay instance here in the address call. So that is how we actually create the deployment script. So that is that for that. So this stop broadcast is very, very important. So we use this to actually stop the broadcast. Now you might be asking, I think I'm still very cool with using Remix. You have to like get mastery of this because this is the industry standard. This is how professional blockchain developers work around deployment and easy code management. So why we use scripts because we can run the same script multiple times. Then it gives us the ability to use version control systems like Git. We do not have to do manual clickings. Like this is the standard way to run things as blockchain developers, and it is professional, this is how real companies actually proceed with their deployment. So the next step, what we have to do now is to actually learn about wallets, right? We have to learn about wallets, how to get the private key from the wallet. But before we do that, we need to actually declare the environment that we would be working on, because on the blockchain we have different kinds of network. I'm quite sure you'd have heard of Ethereum. You should have heard of Ethereum, heard of Polygon, heard of Avalanche, heard of Base. We have quite a number of blockchains, right? So all these blockchains that I've mentioned, they are EVM compatible, meaning they run on the Ethereum virtual machine, but they are deployed on different networks, right? So Ethereum, because it's the primary base chain for EVM, has a network ID of 1. For networks like Avalanche, I think it's 43114. For Polygon, I don't know if it's Ashchain, but I think Polygon was, I can't actually remember, but different networks have their different chain. Now, the next step is that we have to set up our environment configuration before we even get the wallet before we get the private key from our wallet. We have to set up the environment condition. That is, we need to tell Foundry, the network that we'll be deploying to, how to access. Every network also has their own RPC URL, and we also have to get the wallet private key. So you're going to understand all of this, but in this particular tutorial, we'll be deploying it to a testnet called Sepolia. So Sepolia is a testnet. And what is a testnet? A testnet is a pretend network, right? So it's not a real network. It gives us the ability to carry out blockchain operations and ensure that everything works just as they should before we actually use our real money. Now, the first step is that we already know the network that we're deploying to, right? We are deploying to Sepolia. So this is a comment, right? We talked about comments. Comments are codes that we use to explain things, maybe to other developers that the machine will not compile. So we need to get our RPC URL. So a RPC is a remote procedure call. And to easily get the RPC URL, I would recommend that as a professional, as you proceed, you're going to need Alchemy. So if you come online here and you click on Alchemy RPC URL, you can just search for Alchemy RPC URL. It's going to give you quite a number of endpoints. But what I would suggest is you just make sure that you create an account. You can sign in and make sure that you have an account. I already have an account here, but would not be using Alchemy for now because you might not have an account. So an alternative that you can do is I would recommend that you create an Alchemy account. We can just use chain lists. So chain list gives us the ability to access, because we are working on like a tutorial. So you can see that Ethereum has a mainnet of 1, Base, BNB is 56, Base is 8453. There are quite a number of chains here. So it's telling you that helping users connect to EVM powered networks. So all of these are EVM powered networks, but Ethereum is like the pioneer of the space, so it has one. So we need the RPC URL. So to make a deployment on Sepolia chain, so this is the website for Sepolia. Sepolia is a testnet. You can just click sepolia.etherscan.io. Like so, this is Sepolia Explorer. You can see that quite a number of transactions are done, but all of these are test transactions. They are not real transactions. But what we need now is the RPC URL for Sepolia. There are quite a number of them, but we need one. So to get that, we can just search. We can change this our chain list Sepolia RPC. We can just search this. Then if we click on Ethereum Sepolia RPC, we're going to see quite a number of them. We're going to see their latency, score, privacy, and also we can just get one. We're not taking anyone that has the WSS WebSockets. We want to use Hypertext Transfer Protocol. So we're just going to click. Let's go with this. So by clicking on it, we simply copied it. Then we can proceed to use this. So you can either use Alchemy. Another alternative is also Infura. but you can create an alchemy. I'm not promoting any of them. So we already have where we can get the RPC URL. The next step is getting the private key. And this is where you have to exert extreme caution, because if you do let your private key out, if a malicious attacker gets it, the wallet is gone. The person has the ability to move funds as they like. So make sure that you never share this. Make sure that you also never commit it to a version control system like Git, and never take a screenshot of your wallet address. So what we're going to do is, if you do not have MetaMask, I already do have MetaMask installed. You can see it here in my extensions. You can just come to your browser and say install MetaMask, like so. So it's going to tell you to download MetaMask. I already do have MetaMask. Then you can actually install it as an extension. So what I'm just going to say is I'm just going to click on Chrome, right? But I already have MetaMask installed, so I do not have to do all of that. So how do we get the private key? How do you get your private key? Once you have MetaMask installed, it will reflect on the extension side. So I'm going to easily click on MetaMask here, like so. Then I'm going to create a new wallet, use recovery phrase. I'm going to create a password. I'm going to call this 12345. Then, so I'm going to, okay, this is too simple, 7878. So make sure that nobody knows your password. This is because it's a tutorial, right? Then I'm going to click on create password, like so. Then remind me later. That is your phrase. You can keep it in a secure place, very secure place, because that is how you're going to be able to access your wallet. So I'm going to click on done. So with this functionality, we already have remind me later. I'll just click on remind me later, but make sure that you follow this other process if you would be using MetaMask, because you're actually talking about real money here. So we're going to walk around how you are going to get your private key. So we're going to click on account details. Then we're going to click on private keys. Then I'm going to put in my password, like so. Then I'm going to click on confirm. Then I'm going to click on Ethereum. So if I click on this, I have copied my private key. But make sure that you never reveal this. It's very, very important. So now we can easily come back to VS Code, and in our .env, I can replace my private key here with the actual private key that I've copied. So I did not spell this private key. I'm going to change this to TE, then go back to my deploy script and also change this to private. So private should be ATE. So I spelled that wrong, private. Then here also should be PRIVATE. So I'm just going to paste it here like so. Make sure that nobody sees this. This is because of the tutorial. Then also we need the Sepolia RPC URL, because we have to declare the configuration that we're working with, right? I'm going to copy this again. I want to be sure that's correct, so we don't go and have errors. Okay, so this is it, right? Like so. Then also we're going to declare the RPC URL. So I'm just going to create an env. I'm going to environmental variable. I'm going to Sepolia RPC URL is equal to. So I'm going to copy the Sepolia RPC URL that we saw here. I'm just going to copy anyone again. Then I'm going to come back into. Then I'm going to paste it here like so. So with this, we've already made the declaration for our private key, and also we now have the Sepolia RPC URL. So there's one thing else that we need. And why do we need that? We need the Etherscan API key. Now, why we need the Etherscan API key is because we want to ensure that our contracts is verified. So if you go back to sepolia.etherscan.io, you're going to see if there's any this is an address, not a contract. So form 2, I'm going to check this transaction hash, then I'm going to click on, this is not a contract. I'm trying to find a contract, probably an address that has interacted with the contract. So all of these are But all of these are just addresses. I was thinking I'll be able to see a contract. So each contract can be verified on Block Explorer. And because we want a contract that is verified, we always want to verify our contracts. It's in a way it does not guarantee that the contract is safe. It's always intended that you check through the contract code base because it's public on Etherscan, right? But we need an Etherscan API contract address to ensure that when we deploy our contracts, we get to verify it. So where do we get that contract from? We have to go to etherscan.io, not sepolia.etherscan.io, right? So sepolia.etherscan.io is the testnet for Sepolia. Then etherscan.io is the official address for Etherscan. Then you have to sign in here, create an account. So once you're done setting up your account for etherscan.io, if you scroll down to the API dashboard section, I've already created a API token key. You can create yours, just add it. So I'm going to be using this. So I've copied this. Make sure you do copy your own. Then head back to your .env and replace this here like so. You can just call it Etherscan API key. So we have our .env configuration set up. Now, what we have to do is we have to load this environment variables. So to do that, we just have to do source in the Foundry directory, source.env, to load it. So what this function or what this keyword does is that it loads the variables into the terminal session. Now, for us to confirm that everything works just fine, we can do echo Sepolia RPC URL. Then if we hit enter, you see that we get the Sepolia RPC URL that we have already in our .env. Now, I know that this might seem like a lot of setup, but this is actually professional development. Now, always make sure that you store the private keys in the .env, not in your code. And also, the Foundry file configuration comes with a .gitignore. Now, you would see that this .gitignore is for those that do not have idea what Git is. You can look it up. Git is a version control system and a code management platform. Now, the .gitignore that is here, the files, everything listed in the .gitignore, I mean to say, would not be included in your Git commit. So always ensure that your .env is also listed in your gitignore. So all of these files, the cache, out, broadcast, and all would not be pushed to Git. Now also, make sure that for certain credentials like your RPC URL, make sure that you store them in a .env and never add code them. And this is how companies handle their secret. So now let's proceed to deploying our script, since we've already created the deploy script functionality, right? So to deploy our script, we need to ensure that we have test ETH, right? We need to ensure that we have testnet ETH. And how do we confirm that? Now, there are different kinds of chain. I talked about it earlier. We have Ethereum, Avalanche, Polygon, and we have Sepolia. So Sepolia is a testnet, and that is why we're using Sepolia RPC URL. So to make a deployment on chain, remember that in the course of the tutorial, we talked about read transactions and write. You can read from a contract and you can write to a contract. Now, whenever you want to initiate a transaction, what you're simply doing is that you want to write to the blockchain. You're not just reading something. You want to actually make a change. You want to mutate the state of the blockchain. You want to add a series of chain to the pre-existing chains that already exist, right? So to do that, we need to spend money. We need to pay money. We need to pay gas to do that, to carry out that operation. Now, to do that, we need Ethereum in our user wallet. So because we're on Sepolia currently, we need Sepolia testnet ETH, and Sepolia testnet ETH is not actually real money because we're currently on the testnet. So to confirm that you have a balance in your wallet, you can simply do cast. Remember we talked about what cast does. We have Foundry comes with cast, forge, anvil, right? All those tools. So we can do cast balance. Then we can do our wallet address. Let's get our wallet address, right? So our wallet address on MetaMask is this, like so. You should just copy it, copies the address. You can paste it like so. Then we can do Sepolia RPC URL, right? Then we can do Sepolia. How do we have it saved? Sepolia RPC URL. Then also we also need, okay, that's all. So if I hit enter, does it work? There's an argument. Oh, there's a mistake here. I had to have passed in the RPC URL as an option. So right here, I'm just going to do .rpc URL. Then if I hit enter, that should work. So we see that our current balance is 0. So we need a testnet ETH. So this is how you can check a balance, right? This is how you can check the balance of a particular token. So of a particular address, I mean to say. So we have to fund our address because currently the balance is 0. So how do we do that? Now you can see that I recently funded the wallet with $3 Ethereum. I'm going to explain why. So if we search for Sepolia faucet free, let's search for that online. So if a faucet is where we can get testnet tokens. So if we click on Sepolia faucet, right, we're using QuickNode in this faucet.quicknode.com. Then if you click on connect wallet, we can connect to MetaMask because we're using MetaMask in the situation. We're going to select the network to be, we're not using Goerli. I think Goerli is deprecated. We're using Sepolia, right? Then we are going to click on, now if you read the description, it says drop in your wallet address. It tells us that connect your wallet, user wallet must hold at least 0.001 ETH on Ethereum mainnet to use the EVM faucet. So that was why I sent 0.001 to ETH so I can get testnet tokens. So if you click on continue, like so, require wallets have a more established transaction history. Wallet does not currently meet this criteria. So this is giving me a whole lot of stress. I'm going to try another alternative. So I'm going to go back to my long lost love. I'm going to use Alchemy. So Alchemy Sepolia faucet URL. I'm going to click on, I hope Alchemy does not chase me away. Sign in. I do have an account. I'm logged in, I think. Then I'm going to click. I need Ethereum. I'm going to paste my wallet address here. Let me just get my wallet address. Ethereum, receive, copy, then paste it here like so. I already have an account. Invalid format, okay, because of the space. Then I hit send, capture verification field. Let me just refresh, paste this here like so. Then hit send 0.1 ETH. This is revision activity. A wallet does not have enough minute activity. So you can see that the wallet requires that we have quite a number of your wallet must have past activities for you to get gas. So I have successfully been able to get testnet ETH, and I don't know why it became harder. They require that we have you have quite a number of transactions that you've done on Ethereum mainnet to actually be eligible to get the testnet token. So I've been able to work around that. And just in case you've sent Sepolia ETH and you're not seeing it on your end, you simply have to click on all popular network, click on custom, then click on Sepolia. So you can see that we currently have 0.60 Sepolia ETH. So now that we have this, we can proceed to actually run the deployment. So this is what we have to do first. In our terminal here, we can actually write forge script because we're running a script, and do script. Then if you hit tab, you auto suggest deploy then okay, script / deploy. Oh, I'm no longer in SecretPay, and that is why. So I can just cd into, I'm still in SecretPay. I ought to be in the Foundry folder, so I'm just going to cd into Foundry. Then I'm going to hit up, not this. I'm just going to do, I'm going to do forge scripts. Then make sure you're in the Foundry folder, then do script. When you hit tab, you should suggest, then then you should suggest also. Then with this, I also have to do /rpc URL to ensure that to make note that I'm passing in, the next thing I'm passing is the Sepolia RPC URL. The Sepolia RPC URL. Then if I hit enter, it's saying the value is required for, so I think my Sepolia RPC URL probably spelling is wrong. Sepolia RPC URL. So what could be wrong? What am I doing wrong? Deploy forge script. A value is required. Okay, so now you can, what is actually happening is our env is not being read. Because I left the Foundry folder, I can just do source.env, like so. That loads the env. Then if I hit enter, that should work now. So it works. So we're seeing this error, private key failed. So it's saying env failed, passing private key into the missing. Okay, it's mix. Our private key should start with an OX. It's missing the OX prefix. So I'm just going to do OX here, like so. Yes, that should fix the error. Then if we run it again, so this is not an actual deployment, so it does work. So I'm going to explain what this is. This is not an actual deployment. We're testing. What we just did now was that we test the deployment without actually deploying it. So we saw the compiling, we saw the chain ID. This is the chain ID for Sepolia 1115111. Then we can see that said simulation is complete. So this is a simulation. We saw that the transaction is saved to Foundry broadcast. So it created this broadcast folder here for us, right? So this is a dry run test. This is a dry run deployment, and it's not actually the deployment. This is just to confirm that the script works perfectly. So make sure that you add the OX prefix to your private key. Now, let's proceed to do the actual deployment. Now, for the real actual deployment, we're going to do forge script, then also do scripts. Then, like we did before, you can hit tab to complete the auto suggestions. Then we're going to have this. Then also do RPC URL, like so. Then also declare Sepolia. If I hit tab, it should suggest it. Sepolia RPC URL. Then also, the next thing should be this, like so. Then also do broadcast. So this broadcast keyword, I'm going to explain what it does. You should ignore the S at all the S stuffs that you have below. So because I wanted an auto suggestion, so broadcast, then also this, then verify. So this is, I'm going to explain what all of this does. Then the /VVV, we can do 4 V's. Hopefully this should work. Let me take a deep breath. So enter. So we're saying no file changes, no files changed, compilation skipped, encode length match, expected 0. Expected 0 types got 5. So what could be wrong? Let's put on our debug lenses. Firstly, I want to explain what this broadcast does. Now, the broadcast is what we use to actually send a transaction and not just simulate. And also the RPC URL is the flag that helps us mark the network we want to deploy to. The verified tag here helps us to automatically verify the contract on Etherscan, and the VVV here helps us to log everything, like show everything, more like what it's called a verbose output, like it helps us to log the entire details. So we're currently having an error that no files changed, compilation skipped, encode error. So I'm going to increase number of VVV to see more of the logs. Then I'll hit enter again. Still the same thing. So what could be wrong in my logic? Should be for scripts, deploy s.so. What could be wrong here? Let's check together. RPC URL, Sepolia RPC URL. It's quite okay. So I'm just going to copy this. Then I have ChatGPT here installed in my terminal. Then I can just ask it, or I think I'll ask Claude. So let me ask Claude. What could be wrong with the script? What could be wrong? So this is how we debug to with this script. I love this bash command. No. So I'll help you first diagnose what might be wrong. Okay, I'm going to copy this again, allow command to run. RPC URL. It was expecting, so completed fixed command. So what was wrong? So okay, missing contract name. Missing contract name. You need to specify which contract to run. Broadcast, believe missing contract, missing private key flag. This script expects a private key. It has an API. So this is the complete stuff. Quite a lot. So I'm going to try to copy this. Then I'm going to paste this in here. And I'm going to explain what all of that does. I'm going to just get back. So let's see if that should work. I'm going to paste this here like so. But our Etherscan API key is a little bit different, right? Because Etherscan API key, private key, Sepolia RPC URL, the Sepolia RPC URL, then I hit enter. So we have the process being spinned up. So how come did I not even pass Sepolia and all of this? Thanks to Claude. So what we did here, I'm going to explain this now. Now, the forge script, this RPC URL helps us to mark the network that we want to deploy it to. So assuming we were using Ethereum, the RPC URL would be that for Ethereum. The private key, this flag here ensures that the private key is passed, right? Because we need the private key to actually deploy a transaction. Then the broadcast flag here ensures that the transaction is broadcasted on chain. That is, it ensures that we actually send the transaction, not just simulate it. Then the verify tag here ensures that we actually verify that the contract gets verified. And this Etherscan API's key is required to initiate the verification. Then the VVV is like the login, it helps us to see all of the details. So we see that it tells us that the screen ran successfully, then simulated on-chain traces. This is the estimated GUI. GUI is like, if GUI is 1 exponential 18, GUI is like 10 exponential 9. Then the estimated total gas cost is this. This is the gas amount that will be spent. Then it's telling us that it was successful. The contract address is this. And we need this. I'm just going to copy this because we need the contract address, right? So the gas paid, gas times GUI, sequence, all of that. So it was telling us that it was submitting the contract for verification and all of that. Then this is it. So we see that pending in queue, then everything was passed and our contract was verified successfully. So while we've done well, then the transaction also is saved to the broadcast section in deploy.so. So this is the script to actually trigger the deployment with the private key and ensure that it is verified. So we can now proceed to tweak, or we can proceed to check on chain that contract in itself is verified, right? So just in case, if you get an error, insufficient fund, it means that you do not have enough test ETH, or if you get the invalid API key, make sure that you check your API key and that you're using the correct key. Then if you might get an error that maybe none's too high, it means that you can just wait a few seconds and try again. Then just in case you get also more other error, verification failed, you can try to actually verify it manually, and I will show you how to verify your contract manually. So what I need you to do is, I need you to actually grab the contract address here like so, copy it, then let's head back to sepolia.etherscan.io and search for it. So you make sure you come back to sepolia.etherscan.io, then at the search, in the search input here, make sure you can input it, then hit search. So we see that this is a contract address. The current ETH balance is 0, but we do have our contract and it has a green check mark. So is what I was trying to look for on Ethereum before 3 minutes ago. And we can see that it is a verified contract. So it currently has no transactions and all of that stuff. So this is actually good. We've made progress. So on your end, let's say this contract is not verified. When you click for a contract that is not verified, when you click on the contract, you would not see the code. You would not see the code logic, the contract source code. It should just be blank. There will be a button. There will be like a link that tells you to verify. When you click on that verify link, there will be need for you to input your source code showing that you're the owner of that particular contract that was deployed. Select the EVM chain, the Solidity version that matches what you use, then paste the contract, then you can proceed to verify. And you can also check online to see how you can verify a contract without using code logic or doing it from the terminal. So did you see what just happened? With one command here, like so with this command, we were able to actually compile the contract. It compiles it, see that the compiling was successful. We're able to deploy to Sepolia, and we verified it also on Etherscan and got back our contract address. So this is the power of Foundry. You know that in Remix, you have to like click on something, click on compile, then also click on deploy contract. But this gives us the functionality and the power to do everything in one command, in one script. So we already have our contract verified, and that is a good thing for us. So there's also something I want to show you. Well, if we head back to our contract, you can see that we have the code. You can see that everything is actually public. You can see the entire code base that we wrote when we were working on the contract. Then if you click on read contract, you're going to see functions that are read functions. Then if you click on write contract, you're going to see functions that are write functions. So write functions are functions that mutates the states of the blockchain, whereby you have to spend gas. But for read function, we just want to see. Currently, if you click on transfer count, you're going to see that it is a uint and it is 0. Then let's say you want to claim a transfer, create a transfer, refund transfer. You have to connect to a Web3 wallet to actually trigger all of this, right? So we've done amazingly well. The read contract is free, right? But the write contract is not free. So now that we've deployed our contract, let's use our contract from the terminal. Let's try to use everything in our contract from the terminal using Foundry, and that is still the power of Foundry. So what we can do now is we can try to actually call read functions in the terminal. So to interact with functions, we're going to use the cast. Like it's a functionality that Foundry gives us. We're going to do cast call because it's a call function. Then our contract address, I can just get the contract address like so. I can copy it here like so, then paste it. Or you can also create a .env and say contract address, then paste it here like so. I think that's more professional. Then we can do contract address like so. Then we want to interact with the contract right from our terminal. So I can do the / like this. We want to call the transfer count function. I remember that the transfer count, we want to get what the transfer count is. I remember the transfer count was a public variable, and because of that, it serves as a read function. Because it's declared public, right? We do not need to create a function to get transfer count. It's already a public variable, and we can actually tap into it directly, right? Remember I said that public variables can always act as getters, right? Like get functions. So we can just do, to get the transfer count, we can just say transfer count. Remember that right here, the transfer count too is under the read, right? So we can just do call transfer count, then we call it like so, then we specify that it's a uint256 like this. Then we also need to pass in the RPC URL, then do Sepolia. Then if we hit enter, we're seeing transfer count, odd number of digits, invalid value. So what could be wrong here? Cash score transfer count, odd number of digits. So going to see this transfer count. Let me try this without the unt256. So what is wrong? Transfer count. Sometimes it might just be spelling. So we have cash call, contract address. Then, okay, let's see if the contract address is already logged. So I'm just going to cancel this, then do contract address. I'm just going to do source.env to load the contract address again. Then I'm going to use this. So we're having the same thing here, like so. This should work. So I had to have no uint256, enter. So we're still having the same thing. Invalid value, transfer count, invalid stringlet. So what could be causing this error? We're going to copy this also. Cash call, contract address, transfer count, uint256, RPC URL, Sepolia RPC URL. This should work. I'm very sure the error is looking at me. So let Claude save the day. Then I'm going to, what's the possible cause of this error? So we want to identify what the error could be, what could be causing the error, right? So integrating Claude 2 is great if you can give it a shot, because it gets to check your code base, it sees everything and can actually help you. So it's saying the error occurs because cash call is misinterpreting your command. Look at the selected code. I can see that the issue root cause int256 public transfer count, but you're trying to call it as if it's a uint256. However, the main issue is from the command syntax. The correct syntax is int256, but we have it as a uint256. I'm going to be furious if it works. I don't think this would work actually. No space in the signature. The function signature should be with no spaces between the function name, so there should be no space, and I think I did that here, but it still did not work. Return type matches contract. Since your contract declares it, our contract does not declare it as int256. It is actually a uint256. Then the parentheses format should be function name return type, not function. I think it's the same. There should be no space. Invalid stringlet. The invalid stringlet occurs because the space causes cast to interpret transfer count as a contract address, which is in. The error invalid stringlet occurs because the space causes cast to interpret transfer as a contract address, which is in. Okay. So it's telling us to try this, but I know this would not work. Let me not say I'm very sure. So let's copy this and see. So we're still having the same thing. Definitely not, it's not even a uint256. It's not an int, it's a uint. Claude is high. So I'm going to remove contract address here like so. Then also come back here and copy the address. Then just paste the address here straight up, then hit space and hit enter. So it does work. So the error was from, geez, can you see? The error was because when you see a white circle here, it means our .env was not saved. So I'm just going to hit save. So it was not able to read it. So if I rerun this should work. Still the same. Oh, this should be a uint. So this should work now. That should work. Still the same thing. So it means that our contract address is not being, except if I did not spell it to a contract address like so. What's wrong? we should log the contract address. So if I do Sepolia RPC URL, Sepolia RPC URL, like so, there's no file matching Sepolia RPC URL. What is wrong? Something is actually fishy. Like, code can be very funny. So how do we work around settling this? Now, when we pass in the contract address straight up here, it did work. Now I want to confirm that the ENV is being logged in terminal. So sorry, I should do echo. Just going to do echo. I did not pass echo. So echo. So our contract address is an empty string. Then if I do Sepolia RPC URL, Sepolia RPC URL and hit enter, does work. So why is our contract address an empty string? Contract, the address, Holy Mother of Mary, my address had 3 Ds instead of just 2, should be 2. So that was what's causing the error definitely. So if we just hit what we've been trying to run, we still have the same thing. Contract address, contract, cast call contract address, UN256. I'm going to do source.env again, and I'm going to rerun this. So it works now. So the source.env ensure that the new update that I enforced in the .env now works. And I'm sorry that took time. This is actually what you're going to experience in real time. So you're not going to think that I just came on here and had everything sorted. So we do experience these errors as developers, but AI is your friend, obviously. You do not have to do everything alone. It makes debugging faster. So with this, remember that if we go back to the browser and we click on transfer counts, we can as well just see that the transfer count is 0 until somebody triggers a claim transfer, right? And a create transfer, which, yes, it's the claim transfer that updates the state to. So if you check our SecretPay.so, it's in the claim transfer, right? No, it's in the core. It's in the create transfer that increments the transfer count. So by default, the transfer count will always be 0, but you can easily read everything right from here. You also saw that AI also made mistake. So if you do not know what you're doing, you must always have an idea of what you're doing. So with this, we've been able to actually read from the blockchain by simply using the cast functionality that Foundry gives us. So we want to learn how to actually write functions, right? Call write functions in our terminal. And we've already learned how to actually read from our contract from our terminal, right? Using the cast call. Now to create a write function or to integrate or call a write function I don't use the word call, but to integrate a write function straight from the terminal. This is how you can go about it with Foundry. So make sure that you're in the Foundry terminal, like so, then just do source.env. Make sure that you've always initialized like the env in terminal, then you can confirm that by easily doing echo and one of the env file. So if you get it back, it means that the env is already initialized. Then to use the env, we can easily, to use a write function, we're not going to use cast call in this sense, it will be cast send. Then we're going to pass in our contract address that we're integrating, contract address. Then we also now need to call I'm going to go back to the SecretPay. We want to call the create transfer functionality. So we are going to call create transfer, like so, to the name of the function, and the next thing to pass will be the params. It takes an address. It's quite simple to navigate, string. Then it also takes in a UN256 for duration, right? So you must always make sure that the spelling are correct, because you can easily get stuck in calling all of this function, and you do not have to cram any of this. The more you do it, the more like it becomes part and parcel of you. Now, what we have to do next is we now have to actually pass in the values of this parameter. So we need the address, right? So to get the address, I can just come back to MetaMask, switch to the second account and copy the address of Ethereum like so, and I'll head back to, so I paste the address, which is the first parameter. Then I also want to pass in the password. I'm just going to use secrets. 12 has the password. Then it also takes in the duration, which is going to use 60 seconds. Then the next thing that we have to do is we have to, since this is a payable function, we have to pass in, if we send this transaction without attaching an amount, remember that we have you must send ETH validation, right? So we have to send ETH, and to do that we use the -- value flag. Then we attach the value of ETH. I want to send 0.01 ETH. Then we also have to specify the RPC URL that we'll be using, which is Sepolia RPC URL, like so. Sepolia RPC URL. Then also we now have to actually pass the private key, which we would use to sign transactions. Right, so private key, then we'll do private key. So that should work. So we're having an error, that error sending transaction. Then why is he adding this // We do not need any of this. So I'm just going to remove all of them. It's not necessary. Why did he add this /? I think there was a command I pressed on my PC that added all of those. So we do not need any of this. Just going to take it off. Then I remove platform security transfer. I think I mistakenly pressed something in my local machine. So this is wrong. It's just giving me this greater than this. We have a parenthesis. So the secrets 1, 2, 3 ought to be as a string, right? That's is it. Let's just rerun it. I'm just going to rerun everything. I'm going to rerun everything. And the reason why I want to rerun everything is I'm just going to delete this, then cd back into Foundry, right? Then I'll do source.env. Then now I have the env initialize the terminal casts, and then I want to do create transfer. Then I want to pass address, right? It takes in a string and it also takes in U256. So I also want to now pass in the address that I've copied. Hopefully it's no longer copied. So I just want to get the address here like so. Then also I want to pass in the password as 12345, and I now want to pass in the duration. Then I want to specify, because it's a payable function, we want to specify the amount of ETH, which would be 0.01 ETH in my. You can specify any amount that you deem fit. Then the RPC URL. I'm going to do Sepolia RPC URL. I do not know why this is happening. I just tap. I just clicked on tab and it brought that up. I do not want that. So I'm going to remove this. We do not want the /, right? Then also remove this, then remove these two. So our password should be in string, right? So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, the same. Like so. Then 0.01 ETH RPC URL would be, I think I'm just going to type everything by myself, Sepolia RPC URL. Then I'm now going to pass in the private key as a sign transaction. So I know it can be really tasking, but this is how professionals actually walk around. So if you enter, the number is expected. So we have a error. So address string uint256 RPC URL. So my private key should be private key like so. Number is expected. Then we're going to put on our debug lenses and trying to get what the error is. So address, $, create transfer. It takes in the address, takes a string, and it takes a uint256. Then we do value 0.01 ether, and the RPC URL is Sepolia RPC URL, right? Then the private key is private key. So why are we getting this error? Now our contract is no longer showing. Now just after the cast send, we should be passing our contract, right? So we have to fix that. So cast send, the next thing should be a contract address. And I think it was that error was from my end. So we're just going to do contract address. Then if we hit enter, we're still having number is expected. So number is expected where? So let's see, cast send, contract address, create transfer, then it takes address, string, and a uint256. I'm just going to give it to Claude. So this is Claude. I'm going to paste it here. Why this error? Let's see what it has to say. Man, I'm feeling fly. ChatGPT on the left, Claude on the right. So he says, notice, okay, let's see what he's saying. He's saying there expected a share related issue with your passing the value 60 is interpreting the command incorrectly. The class problem is it express the final signature and argument in a specific format. Try the solution. Cast send this 1 2 3 4 5 then 60. So let's copy the first one that it suggests and see what it does say. So I can see the error already. Now, what was happening was because we are not wrapping the create transfer. This is a function signature, and everything in here within these two places should be wrapped in string, and that was what was causing the error, right? So it was not. We ought to have passed it as a function signature, right? So like this and like this. So these are the errors that you most likely will come across. Then if you hit enter, it should work. So that should work now. Claude, thank you. So this is how you can debug. So you see that this transaction goes through. We see the block hash, the block number, the contract address, even though it's not clearly written, and the cumulative gas spend and the logs. So if we head back to etherscan.io, we're going to see, although I've populated some transaction, we're going to see a new transaction. This was some other transaction that I initiated. You're going to see that a transaction was initiated 23 seconds ago, right? So that is all about writing. You can see that a new create transfer function has been logged. Assuming this contract was not verified, you would see that this would not be written as create transfer. It's just be 0x00 something. So look at what you just did. We just created a transfer function. We called the create transfer function from the terminal. We did not need to click on any new UI. We did everything purely from the command line. So with these abilities, you've now understood how Remix and Foundry integration can be done, right? You've learned how to actually create contracts. You can build code and test on Foundry. We also actually, when we use Remix, you learned the basic of Solidity. You learned how to actually declare the Solidity version that we're using, how to create a contract, and also how to actually test and compile them and see if they work well. Now, Remix is great for learning and for quick tests, but Foundry is where professional workflow is being done for real project. So most developers actually start with Remix like you did, and then they proceed to move to Foundry for serious work. But now you have the tools, both tools in your toolbox, and that is so amazing to hear. So it's important to actually try to practice everything that we've learned here in Foundry, from Foundry installation, how to initialize it, and how to understand the workflow, running Forge build to compile, and all of that stuff. So the practices that you have to add more is the security approach, gas optimization, how to ensure that your function are not gas expensive. And there's one thing I also want to mention. I should have done this earlier. Firstly, if you're new to using Solidity in VS Code, your linter might not be rendering everything like this. So you have to install an extension by clicking this particular icon on the left side that looks like this. Then search for Solidity. Then once you click on it, make sure that you have this installed in VS Code, right? And it's very, very important to help you clearly format your Solidity code base in particular. So congratulations, you just learned professional blockchain development, and now you know 2 ways to deploy smart contracts. Firstly, the Remix way, which is browser based, where you have to click through UIs, and now you also know how to make deployments through Foundry, which is the terminal based way. Foundry is scripted and automated, and it is the industry standard, and we use it for professional workflow. So most blockchain companies actually use Foundry or a framework called Adapt, which is a similar tool for people that are quite familiar with JavaScript. So one thing that I'm very sure that you can see now is that you're proficient in smart contract development using both Remix for rapid prototyping and also Foundry for production development. So it's a professional level statement that you should actually be proud to always represent. So amazing work so far, so good. So I leave you to actually building more projects and getting much more better in blockchain development. Thank you. So we've done everything that we need to do. We've deployed our contract. It's live on the blockchain. We've run the cast call and the cast send to actually see that everything works well. We interacted with the blockchain using the cast functionality that Forge gives us, and everything is great. But I thought about it that it wouldn't be good if I didn't actually lay this fundamental. I intended to have closed like the tutorial at the last video that you just watched, but I thought about talking about smart contract testing, and it is very, very important because we've built an amazing contract. We learned how to do that in Remix. We also came down to VS Code and implemented Foundry. We've even deployed it. But there's a question that should actually terrify us. Now, the question would be that, are we sure that our contract works correctly? What if someone finds a way to claim a transfer twice? Or what if the deadline check has a bug? Or what if a refund can be claimed before the deadline? So on a real blockchain with real money, bugs can actually cost developers or companies millions of dollars. And let me talk about some real examples. Now, in 2016, there was a DAO hack, Decentralized Autonomous Organization hack, whereby it was a reentrancy bug vulnerability. And it did cost $60 million. In that particular hack, $60 million was stolen. And it was because they didn't test enough with recursive calls. And that led to the creation of ETC, Ethereum Classic. Like there was a hard fork in the Ethereum blockchain. But assuming adequate test has been carried out, the reentrancy bug would have been fixed. Also, we've seen quite a number of hacks in the cryptocurrency space. I think with Parity Wallet, the Beanstalk hack, and quite a number of hacks. So the patterns for this hack would be that there were no comprehensive tests, then there were not sufficient test cases, and the deployments were made without audits. Yes, and that led to the cost of millions of dollars. So we want to be, for this our particular SecretPay contract, we want to write enough test code. Then we want to test every possible scenarios, and to save us quite the amount of money, right? To save us from hacks. So right now, our SecretPay has 0 automated tests. If you look at the Foundry directory, if you click on test, we have no tests, right? So we actually manually tested it in Remix. If you remember, we tried to see if the create transfer worked, if the claim was successful, and if the users got their refund. But we did not test. What if someone claims with the wrong password? What if the deadline is passed? Like the other things we did not do. So manual testing can never and would not cover everything. So this is why professional developers write automated tests. So tests are code that actually test our code. That's funny. So think of it like our smart contract is the product and the test is the quality control that we do before shipping. So no professional developer should actually deploy without tests ever. So right now we're going to learn how to write tests like professionals, right? So let me show you what testing actually looks like. So if we come to our test in our test folder, we can create a file and name it. Let's just call it test.t.so, right? So I'm just going to call this tests.t.so. Well, I'm going to name it since our contract name is secretpay.so, I'm going to call it create file. I'm going to say secretpay.test.t.so. I'm just going to do something like this here. So that would indicate that it's actually a test file, right? And I don't know why this is loading. Create file participant. So the essence of this is that we want to actually see that our SecretPay code base works without any possible error. I don't know why my VS Code is taking time. Let's just wait. So the first thing to do is that we have to declare our license identifier, right? We have to declare our license identifier. So I can go to secretpay.so. In my deploy.so, I'm just going to copy this like so, then paste it in my secretpay.so. Then the next step that I want to do is I want to import. Remember that in our deploy, when we were writing the deploy script, we imported the script.so from Forge std. Then I'm just going to copy this line here like so. Then in my test, I'm going to paste it, but not, since this is not a script directory, we want to run test. I'm just going to turn this to test.so. So we're going to import the test functionality that comes with Foundry. Then the next step will be to actually import our contract to test. So I'm going to actually just copy it here like so, then paste it here like so. So with this, we've imported our contract. Then the next step will be to create the test contract. And how do we do that? So simply create a test contract. We're going to use the keyboard contract like we always do. Then we're going to pass in the name of the contract. Then we can call this SecretPay test, right? Then we can say is test. So just like how the deploy script inherits script, we're going to make our contract, the test contract, to inherit test, right? Now we have this in play. Then the next thing that we have to do now is to actually declare a contract instance. So to declare the contract instance, we can just do secretpay, right? Then we do public then also do SecretPay. Like so. So with this functionality, we've declared the contract instance, and this instance is an instance of our contract, right? Then now we can create an address. So the address that we'll be creating, because actual users are actually integrating or interacting with our SecretPay contract, we have to create test users, right? So the test users will be the one to create a transfer, to try to claim a transfer and all of that. So let's create 2 test users, or 1. We can create 2. And like I'm going to say, to create a test user, I'm going to say address of Alice. That is, Alice is type of address, right? Then I'm going to just do address. I'm going to call this OX1. Then also, we're going to do address for Bob. So I'm creating 2 test users. I'm going to say address OX, like so. So we have created our test users. So the next step will be to create a setup function. And to do that, we can just do function setup, right? So I want to use camera casing. Then this function will be public, right? Then this setup function is going to run before each test. That is our intention. So the setup function is going to run before each test that will be carried out. So to do that, we can now actually try. Now, before any test comes up, we want to actually deploy the contract. So before any users can, remember that the flow of a test will be that before any user can actually call the create transfer, the contract must have existed. That is, the contract must have been deployed. So this setup function will run before each test. Now, to do that, we can actually deploy the contract first, because before any test is carried out, I want to ensure that the contract has been deployed. So I can do SecretPay is equal to this instance that was created here. We can do SecretPay is equal to new SecretPay. So this helps us to create an instance of the contract. Now, what do you think we have to do? Now, we've actually deployed a fresh contract instance. Now, we want a test user, to be able to actually give test ETH. Right? You want a test user to be able to actually give test ETH in the contract. So to do that, we can use the VM keyword, VM.deal. This is how we actually do that. Then we can do Alice, to pass in the test user. Then we pass in the value that the user wants to give. That will be 10 ETH. Then also we can actually do vm.deal for Bob, right? And we also pass in the value that Bob wants to give. So what we're doing here is we're actually giving Alice 10 ETH. That is the user that we're creating. We're giving this user here, Alice, 10 ETH. Then we're also giving Bob 10 ETH. Right? Remember that these are not real money. We're currently in development. So this functionality here, we're giving Alice 10 ETH and we're also giving Bob 10 ETH. So this setup function would run before each test function, So let's create the test. Now remember that in our src file that we have here, we have the create transfer function. So what we want to do now is we want to create a test create transfer function. So I'm going to say function test create transfer function, like so. Let's create transfer function. So this function is also going to be public, right? Now there's something that you must put in mind. Every test function in Foundry must start with the test keyword. It must start with this word test. It's very, very important. Now, the next step will be that we want to arrange the setup for the test data. Now, if you remember, our test function in our create transfer in our SecretPay also takes in 3 parameters, right? It takes in what? A recipient, it takes in a password, and it also takes in a duration. And remember that the function is also known to be payable. It's a payable function, right? Please ignore this. the function is a payable function. So what can we do? We have to actually now pass in the parameters. We have to set up the test data for our function. Now to do that, because the SecretPay takes in a recipient first, we can do address of recipient, right? Then we can say that that recipient is Bob. Remember that we already created this test users here. Then the next thing would be to actually declare the password. So we can say password is of type string, memory. Then we can just call the password secret. 1, 2, 3, like so. Then the next thing is the duration, right? So we can do UN256 duration is equal to 1 days. Then what else? I'm just going to say, now remember that this SecretPay.so function is payable. It's a payable function, right? So we have to send ether alongside when we're calling the create transfer function. So I can just do uint. Also I can do uint 256 amount is equal to 1 ether, like so. So we are actually good to go. So what is the next thing that we actually now have to do? Now, since we've set up the test data, right, the next thing that we have to do is to do the testing, right? So to do the testing, we've set up the data like so. The next thing we want to do is actually mimic Alice. So we want to pretend that we are Alice. That is, Alice is the one calling the create transfer function. I remember that before we did any of this, before this test create transfer function will work, the setup function here would always run before each test function. Please put that in mind. So it means that before this test create transfer function would run, we would have actually funded Alice with 10 ether. So the next step is that we want to act as if Alice is the one calling the test create transfer function. And to do that, we use virtual machine.prank, right? Then we prank, like we pretend that we are Alice. Then we can now proceed to call the create transfer function. And to do that, we can simply do SecretPay. We use the contract instance that we created, right? The create transfer, like so. Then the next thing is that since this create transfer is a payable function, we want to attach the value that we're transferring, and the value here is what we've declared here, which is what? Amount. So I would do amount, like so. So amount is what we are sending. And I can also now pass in the other parameters, which will be recipient, right? Then also password and also duration. So with this, we've called the create transfer function. Remember that we're expecting that this create transfer function is an instance, that is, it's a function that exists on our SecretPay contract. So we now have to actually run checks to see if everything works correctly. So to do that, we can use the assert, right? So the assert, we want to be sure if the assert, this EQ means equal to, we want to run a check to see if the transfer count, not transfer count, I have to do SecretPay dot transfer count. Remember that transfer count is a public variable here, like so. Transfer count, we created this transfer count. Where is it? We created this transfer count variable here. Then remember that in our constructor we initiated it to 0, so by default it will be 0. But whenever a user calls the create transfer function, what happens? Remember, we increment the transfer count by 1. It's the same thing that by saying transfer count is equal to transfer. Remember that we declared that we said that it's the same thing like this, right? This is the same thing as doing transfer count plus plus. So whenever a user calls this create transfer function, we are actually incrementing transfer count. So it means that whenever Alice calls this create transfer function, the transfer count should become 0 plus 1, which would now be 1. So we want to check if the transfer count, the SecretPay transfer count, is equal to 1, right? So I'm going to call it here like so. If it is equal to 1, then that is all for that. So we want to be sure if it is equal to 1. So let me break everything down that we just did. So what we just did here was, at the very top, we imported the MIT, we imported the license identifier. We also declared this validity, the version of Solidity that we're using. Then also we imported Foundry test functionality using the Forge STD test also. Then this particular import that we did, it gave us the ability to actually use Solidity Foundry testing powers like the VM.prank that we used here, the VM.deal. Now the VM.prank allows us to pretend to be someone else. The VM.deal allows us to give addresses ETH. Then the assert equal to what you see, the assert EQ, it checks if values matches. Then what other thing? I think that is all for now. That is all that we have specified in here, right? So what else? We also created the SecretPay test. Then we ensured that in inherit test, right? That is, it gives us the functionality to inherit test. Then we now declared our contract instance here like so. We funded Alice and Bob with Ether. Then we also call the setup function. The setup function would always run before each test function, right? So this functionality here ensures that we deploy a fresh contract first. Then it also ensures that we fund every user with actually test ETH. So whenever a test function is carried out, this will be triggered first. Now, we've actually set up a test for this create transfer function, right? So what are the next thing that we need to do to ensure that everything works just well? So we need to now actually talk about the industry standard. Now, the industry standard follows a AAA pattern. I'm going to comment this out. It follows this pattern. Now, the first pattern, the first A means arrange. The second pattern is act. Then the third one is assert. This is the pattern that it follows, right? So we must arrange, we must set up the test conditions, we must act, that is, execute the functions that we have. That is, we must execute the function that are being tested. Then we must also verify the result. So if you notice, this here prepares the test for everything that we need, right? It prepares the test for everything that we need. I mean this, it prepares the test for everything that we need. The act is where we get to actually call this. We prank as if we were Alice. Then we also call the create transfer function. Then the verify is where we actually verify that the SecretPay transfer count matches what we expect it to match. So this is the industry standard, the AAA pattern, arrange, act, and assert. This pattern is very important because it helps us with a clear structure and it gives us the ability to easily debug our errors, and it's the professional industry pattern, right? So the AAA pattern makes our tests very readable and maintainable. And I'm re-emphasizing all of this because tests are, in fact, you cannot say that you're a professional software blockchain developers without having good knowledge about tests. So when a test fails, yes, they will. We can immediately see when those tests fail, we can easily see where the error is coming from. Is it from the setup? Is it what did we do? Is it what we did? And what did we expect? So the arrange, act, and actually assert pattern are very important in proceeding with tests because it's the industry standard. Now, I'm going to show you a complete test suite for SecretPay. So this will test it's going to test if everything works correctly, if the test should fail, because there's sometimes that the test should fail if we're going to handle attack attempts and other weird scenarios. So let's proceed to write the complete test code. Now, we've actually created a test for secret to test create transfer function, right? Now, we want to actually now follow the best procedure. So now we're going to be doing everything using the industry standard procedure, like using the best possible procedure that exists. So I want you to put on your debugging lenses, because we're going to be writing quite a number of tests. And trust me, I'm sure we're going to run into errors, but we're developers, right? And we have powerful AI tools that can help us debug along the way. So now, initially, we created these state variables at the top, that is a user of Alice and a user of Bob. So what we want to do first is we want to use the best approach, right? So we want to use readable names, more readable names. So if I'm to rewrite this as a professional, I'm going to say the address, then I'm going to call this address, I'm going to give it public. It's going to be public, right? The identifier will be public. Then I'm going to say Alice. So I created a variable here of Alice of type address, and it is public. Then because I want this address to be a readable name, I can use the make address functionality. So I'm just going to do make ADRR. This is how you call it. Then I'm going to say Alice. So if we were to do for Bob, how do you think we're going to do it? So this is going to be, we're going to use Alice as the sender address. Then if we were to do for Bob, I'm just going to copy this here like so, paste it just below, and I'm going to say Bob, then also change this to Bob, right? So we're making progress. So this generates a address for both Alice and Bob, right? So because we also want to test for a scenario whereby an attacker tries to do something on our contract, we can also proceed to create an address for an attacker. So still, I'm just going to paste this here like so. Then I'm going to call, what should we give the attacker? Let's give the attacker Charlie. Let's use Charles. Right, let's use Charles. If you're Charles, I'm sorry. So let's use Charles for the attacker. So we also want to create quite a number of state variables that we would be using in our test contract functions, so we don't have to always redeclare them. And to think of it, we're also going to need a password, right? So because that password would be something that would not change, we want to declare it as a constant. So I'm going to say string, then I'm going to say constant. So it's going to be, that variable would be a constant. And in Solidity, it's conventional to always store password in constant in cap lock. So I'm going to say password like so. Then you can call the password secret 123 like so. So what other thing do you think we're going to need? Okay, so let's say another user somebody tries to withdraw the money. Let's say Bob or Charles tried to withdraw the money with a wrong password. Would be using a wrong password, right? In the test function, to test to see that when a user tries to use a wrong password, the contract should fail. The contract should not allow it. So we can just copy this here like so, then paste it below. Then this should have a semicolon. Then I'm going to say wrong password. Then I'm going to say secret 113. We can leave it like that, right? Then we're also going to create a transfer amount, because we'll be using this to actually we'll just be using it as the value when the user makes a transfer, right? So these are the state variables that would most likely be using in our test function. So I can do UN256. I'll do transfer amount. This would also be a constant transfer amount. Then I can just say 1 year. And you're going to see why we're doing all of this. It's going to save us quite a number of stress. I'm going to have to say constant, like so, constant. I'm used to writing that in JavaScript. Then what else do we need? We also need the duration, right? So we don't always have to declare duration, because remember in our SecretPay so it takes recipient, password, and duration. So we're declaring the state variables at the very top, so we do not have to declare them all the time. I remember when you just say uint, so this is automatically going to treat it as uint256, but just to be more clear, in case other developers sees our code, we want to actually use 256. So now we want the duration to be constant too. And constant, what we're declaring that is constant is when we talk about gas efficiency in Solidity, when you declare a constant, it makes like the contract more cheaper, right? So it does not take too much space in memory. So I'm just going to say uint256 is constant, because it's not a dynamic data. We're just assigning a particular value to it. So I'm just going to say duration. Now constant, we're using cap locks because it's type constant. Then I can just say 1 day, like so, 1 day. So we've declared our state variables, right? So another thing that we can do is we can also copy the events that we have in our SecretPay. So we'll be needing that. We can just go to the top here, the events that we have, because we'll be needing it for testing, right? So let's just paste it just below here, like so. Events, I'm just going to, I don't know why my printer is not linked in Solidity well. So we need to like just copy the event for testing purposes. Now, the next thing will be the setup, right? The next thing is going to be our setup. So we need to actually deploy a fresh contract like we have here, like so. Then we need to give our test users Ether, right? So here we're giving Alice and Bob, right? We're giving them test Ether. Let's also give Charles test Ether. So I'm just going to copy this here, like so. Then paste it. Then let's do Charles. Now we've given both Alice, Bob, and Charles test Ether, right? So let's now remodify our test create transfer function to the best states that we know, right? So what we can do is, if I comment all of this out, at first here we see that we assigned the recipient. We created recipient variable to be Bob. Then we also now say that the password or a memory, we created this password string of memory. It should have a name here, like so. This should be password. That was a mistake on my end, right? We have to define whatever we said. It is password 1, 2, 3 and all of that, but we want to use the best possible approach right now. So the first step is what we have to arrange before we act and before we assert, right? So to do all of this, we can first we need to know the initial count. That is, we need to know the transfer count. I remember that in our constructor, we initialized it to 0, right? Because we're always going to be using the transfer count, because it's that transfer count that we mapped to be the ID of transfers. If you remember in our mappings right here, we mapped transfers to be that uint256 to be transfer count, right? So we want to know the initial count, right? So to do that, we can just do uint256 like so. Then we can now say initial count, right? Initial count is equal to SecretPay, the contract that we deploy dot transfer count. So automatically, I know you should know that this will be 0 if it's the first transfer, right? So transfer count like so. So with this, we've actually gotten this. So what else do you think that we're going to be needing? We're also going to be needing the expected deadline, right? Because our SecretPay.so takes what? It takes in recipient memory and duration, right? And we know that for this functionality, the sender, the person that is creating the transfer, is going to associate the deadline that the person, the claimer, the recipient has to claim the money, right? So we want to arrange what we would be needing. So we need the expected deadline. It's going to be what type of data? It's going to be a unit 256 also. So I'm just going to say expected deadline, like so, right? So how do we get the expected deadline? We can simply do block, right? Block the timestamp, that is the time whereby that transaction was mined, plus the expected deadline. It will not be the duration, what we declared here at the top, right? The duration. So we're going to say duration. Then what other thing would we be needing? Are we needing any other thing? No. Remember that the claim transfer in our SecretPay also, the create transfer takes in a recipient. We've declared what the recipient is here in our test, right? We said that Alice is the sender, right? And Bob is the recipient, and also Charles is the attacker, right? So we know in our SecretPay so we want to pass in the recipient, want to pass in the password. We've declared what the password is here at the very top. We said that the password is secret123. So we now have to act. Now to act, we simply have to prefend, right? We've arranged everything that we need. We've arranged the recipient. We've arranged the password. We've also arranged the duration. We've also tried to get the initial count and the expected deadline, right? So we now have to act. So how do we act? We have to pretend that we are Alice. I'm just going to uncomment this out. So to pretend, we're going to prank the test create transfer function that we are Alice, right? So the next step will also to be to call the SecretPay create transfer, pass in value and the amount we want to send. So we just have to change amount now to what? Transfer amount, right? Because we already created it at the very top here as a state variable. I'm just going to say transfer amount, like so, right? That's it. Transfer. Is the spelling, my spelling right? Transfer. Let me just copy this here, like so. Then do transfer amount, replace it just to be sure. Then also we pass in the other parameters. Now recipients will no longer be recipient. Recipients would now be Bob, right? Then password would be what? Password in caps lock, right? Because we declared it at the top as a constant. So we'll say password. Then also the duration would now be duration, right? So duration. So when the person is calling the create transfer, is passing, when Alice is calling the create transfer, she's sending ether, and that is why we attach this value here as transfer amount, because it's a payable function. She's sending, where she's also passing the recipient, the password, and the duration, and that is what we've attached here: the recipient, the password, and the duration. Then the last step would be to what? Assert. We want to be sure if everything matches what we expect. We want to be, now for this scenario in particular, we want to ensure that the transfer count, remember that when a user creates a transfer, the transfer count increments, and initially the transfer count was 0, but because the person just called the create transfer function, we expect the transfer count to now be what? 1, right? So this is where we get to assert. So we've arranged, right? We've arranged here. I can remove all of this now, right? So we've arranged here. We've acted, and now we are asserting. Now, what other thing do you think we have to actually check for? Do you think we have to check for anything? So what we can do is we can also check the transfer details. But before we do that, let us run, we're currently in the Foundry directory. Let's run forge test to see if it works. Forge test. So we see that it does not work, and it's telling us that at line 16, we used in 256. It's telling us constant transfer amount is equal to 1 letter. You say expected this but got you into 50. So let's go back to line 16. So on line 16, you into 5. So it's telling us what is the error. It means that we did not pass a semicolon here, right? So this ought to have a semicolon. And also, let's check down here too, there ought to be a semicolon. So let's run forge test again. You can just hit the up key, the up arrow in your keyboard and hit enter. So we're seeing an error again. We're seeing expected in line 42. I ought to have passed in line 42 here, just here. I did not pass a semicolon also. So that was why we're getting that line. Let's run. So I know we're going to come in contact quite a number of errors. Then line 49, I did the same thing. I did not pass a semicolon here. Like so. Also here, there should be a semicolon. Then hopefully everything should work. So we're saying, did you mean make address? So the R should be just 1. The R should be just 1 for make address. So it shows that I'm not a robot. I'm a human being just like you. So these are the errors that you might run into. Did you mean, so it should be 2D. 2D like so. Right, make. So let's run it. So we're seeing initial count, unused local variables. Okay, we are having unused local variables. And it's saying found invalid setup function. Did you mean setup? So quite remember, this is a warning. You can ignore the expected deadline warning. It's just telling us that we did not use them, but we declared them. So why are we not using them? But we're going to attend to that. I'm just finding my mistakes very funny. Like this should be said, you should be the one in capital letter. And let's run it again. Permit me, please. Then it's for test. So we see now that while we're getting one, we're going to use all of this, like the initial count and all. Then also, we're going to use all of this unused variable. But now you can see that run one test for SecretPay.so, and it tells us that that test in particular passes. Now, it says test create function, gas use, it tells us gas use, it tells us that everything goes well, right? Now, our test does work. You can ignore the unused local variable because we declared them, but we did not use them. So, let's say we want to log more details when we run our test. You can see the funny errors that I ran into. It's something that happens. We're developers. We always come in contact with bugs, right? But we have more things to spray them. So let's say you get more error in course of writing your code. So you can actually have more logs. Like you can use more verbose operations. So to do that, you can just do for test. We've done something like that during deployment. You can just do -vv. So in case there's an error, you get to see like more details. But because we did not get any error, it just so that the test ran. So now let's proceed to now what we're just checking is we're checking that the transfer count, after the create transfer is triggered, the transfer count increments to 1. So what we can also do is we can also check for transfer details, right? So we can, in here, like so, we can check for transfer details, like if it corresponds. And what we can do, I'm going to do is like this, right? I'm going to do SecretPay, that is the contract instance that we do create here. This, I'm just going to do SecretPay.transfers. Now, I want you to start imagining when the user calls this create transfer function, at that particular time when the user is calling the create transfer function, what is the transfer count going to be? The transfer count at the point of calling this create transfer function will be 0, right? It is when this create transfer function is done, that is when it increments to 1, right? So it means that this particular create transfer function, that is this particular create transfer function, the transfer count will be what? 0. It is when it is done that it increments to 1, right? So it means that the mappings here of transfers, that ID will be 0. Remember that this transfers is a mapping that maps a UN256 to a transfer, to a transfer, right? Because we created a struct. So remember that this struct takes in as a variable of sender, recipient, amount, password hash, deadline, and claimed. So it means that to get the first transfer, we simply need to pass in the ID UN256 of 0, right? Because we are setting this transfers here mapping, this mapping of transfers here. At this particular point, we are passing in the transfer count. So it means that transfers at 0 will be equal to the first transfer that Alice calls, right? I hope that is clear. That's why I had to revisit it. So if we want to get the mapping, right? If we want to get the transfer that occurs at map 1, it will mean that we have to pass in 0, right? Because automatically when Alice calls this create transfer function first, transfer count will still be 0, right? Transfer count will still be 0, and transfers is the mapping, right? So to get that particular details of this transfer, we simply need to tap into 0, right? So don't confuse this. Do not get confused with this. Like this, only transfer count only becomes 1 when the create transfer function has been called successfully. But now we want to get the transfer details of this particular transfer, so it will still be 0. And I have to just revisit this so that you will get it clear. So now to get the transfer details, we can simply do I intentionally did this first, right? So I intentionally did this first, so we can do address. We're going to more like destructuring. We're going to do address sender, like so. Then we're going to do address recipient, right? Then also what other details will be in the transfer. We can also get in the amount of that particular transfer, amount. Then what other thing? We can also get the deadline, the password, the deadline, and check if it is claimed. Remember that every transfer, that is what is in the struct, right? A struct gives the ability to create a unique data set. So the struct has sender, recipient, amount, password hash, deadline, and claim. And that is what we want to destructure out of that particular transfer. So we're just going to say here so what else do we need? We need the password hash, and it's bytes 32. Remember we hashed this case at 256, right? Then we're going to say password hash. Then we also need the deadline unit 256 deadline. Then we also want to check if it has been claimed, like so. All right, so I don't want to show this. So this is we getting tapping from the variables that are in that particular transfer that Alice calls. So we want to now run another assert. So we're going to say assert, right? EQ, can just say EQ, right? Assert. We want to run an assert that checks if the sender, right, is equal to Alice. So we want to run an assert to check that if the sender of this particular transfer is Alice, right? So we can now do Alice. So with this, we are actually checking our test. We can even proceed to add a string here and say sender should be Alice. And just even here, we can also say, for more clarity, transfer. Just here, I can say transfer should be incremented to 1, like so. So we can add a string to actually enforce, right? Then what other thing can we check? We can also check for the recipient. So I'm just going to copy this because of time, like so. I'm just going to do Command C, then Command V. I'm going to say recipient, then recipient. So I'm going to say recipient should be Bob. So I hope you're getting the hang of it. So tests are really interesting. Recipient should be Bob. So we have to run quite a number of tests. And the reason why tests are important is they're important because we have to do quite a number of them before we even ensure that before users start spending real money in our tokens to prevent errors that might happen, right? Then we can also check for the amount. So that's why I said it's going to take a lot of time. So we can check for amount. So I'm just going to stop our amount and leave the rest to you. Then I'm going to run another function. I can say amount is equal to what? This should not be recipient. This should be Bob. Then amount should be the transfer amount that we declared here at the top, right? So I'm just going to say transfer amount. Amount like so. Then I should say amount should match. Then amount should match like so. So we have this. You can add more things like the expected deadline, the claimed, right? So you know that claimed should be false. So if you were to do that, you're just going to do assert EQ, then claimed, right? Claimed should be false. You expect claimed to be false. Then you can pass in a string. So it's going to be claimed, assert EQ, claimed, then the comma, then the next one will be false. Then the next comma would be should not be claimed because you expect that the transfer was just created and it should not be claimed. So let's run the test and see if everything works. So it's saying, okay, expect this here like so, semicolon, 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 and semicolon, right? So let's run it and see if it works well. So we see that, please ignore this. So it's telling us that you declared deadline and you declared book claim, but you did not use it. So it's just a warning, right? So our test does work. Now, we can now proceed to actually verify, right? We can proceed to verify the password. I want to talk about that. Now, we can proceed to verify that the password hash is correct. So how do we do that? Remember that the password is what? Type bytes 32, right? So we can say that bytes 32. We're going to create an expected hash, right? Variable. So I'm going to say expected hash. Expected hash is equal to, then we're going to hash vksac 256, right? Then we're going to say abi.encode packed, right? Encode packed, then do password. You don't have to cram all of this. The more you do that, it becomes part of you, right? So with this, this is the hash we're expecting, right? So we're going to have an assert EQ. So assert EQ. Then this should also have a semicolon to prevent further error. Then I can now I'm expecting what? The password hash, right? To be equal to the expected hash. Remember that the transfers, we're not storing the password as pure string, right? So we're hashing this password here, secret123, right? Then we're expecting that this password here matches the hash password, the expected password that we hashed here, right? So that is what we're doing. So we're just going to say password hash matches the expected hash. So we can also add a string to say password hash should match bytes. So I'm quite sure that there might be an error. Okay, so it does work. Everything does work. So we're making progress. So we've, in a more professional way, we've written our first test create transfer function. Remember, every test must start with the keyword test. Now, we can also call a function. Now, that function, we can also create another test to confirm that after this test create transfer function occurs, an event is emitted. Remember that if we go back to our SecretPay.so in the create transfer function, after all of this is done, we emit an event, then we increment transfer count, right? So we want to actually enforce that. We want to have a test that checks that an event is emitted, right? So let's do that together. So once again, put on your debugging. So we're going to have a function, right? It's going to have the keyword function. Then how are we going to name it? It has to have test first, right? Then we can call it test create transfer emit event. Let's call it that, test create transfer emit event, like so. So we can see that function is public, right? Then we can now start thinking, now what's the first thing that we need to do? We need to arrange, right? We need to act, and we also need to assert, right? So in doing all of this, the first thing that we need the transfer ID, right? So we need the transfer ID. So I'm going to do uint 256 transfer ID, and you're going to, now you might be asking, why do we need the transfer ID? In this transfer created event, if you scroll to the top, it takes the transfer ID, it takes sender, it takes recipient, amount, and deadline. I remember that we said that this index helps us to it helps with facilitating for easy filtering and better filtering. And per event, we can have maximum of indexed variables that we can have is just 3. But we mentioned that when we are at Remix. So firstly, we need to arrange. We need the transfer ID first. And how do we get the transfer ID? We can simply just do transfer ID is equal to the instance of the contract, SecretPay, right? SecretPay, we call it like so. Then we do .transfer. Sorry, SecretPay.transfer count. Then we call it like so. So this should also have that. Then the next thing that we need to do is we also need the expected deadline. So I'm just going to copy this here like so. We also need the expected deadline, right? If we check what's it takes in deadline to, we already know what the sender is, right? We declared the sender at the top here, right? Sender, recipient, and we also declared the deadline. So we also declared the duration, I mean to say, not deadline, we declared the duration to be. So this takes transfer ID, recipient, amount, and deadline. So now we've arranged, let's go back here. So we've actually we've got the variable for transfer ID for expected deadline. Now we need to expect the event. That is the next thing. Now, because we know that the create transfer function emits an event, we expect the event to happen, right? So to do that, we can do vm.expect_emit, because events are emitted. And we talked about how events are like notifications on the blockchain. It helps other applications like fronted apps to be able to see that certain things have occurred on our blockchain, right? So it's like notification that this thing has been triggered, and fronted apps can listen for events using webhooks. So if you dive deeper into Alchemy, you can see that you can set up event listeners on the blockchain. That's why if you've ever come across more like a maybe if there's this wheel alert on Twitter, there are certain times that when certain notifications or certain transactions that are huge occurs on the blockchain, you see that there's a wheel alert. That is an API that is listening for an event on the blockchain, right? So it's a very interesting topic, but let's just stick with what we're doing now. So now we expect an event to be emitted once the create transfer is triggered, right? So we're going to do expect emit, right? That is how we do true like so. Then also now we're expecting how many parameters? We're expecting 4, right? 1, 2, 3, 4, 5, right? So we're expecting 1, 2, 3, 4, 5 parameters, right? So we're expecting an event, so we can just do expect emit. This will be true, and true, right? So with this, we're expecting the event. Then the next thing to do will be that we have to now emit the event. So we can just say emit transfer should be emit transfer, right? Transfer created, like so. Then we pass in the values, right? So we're going to pass in the transfer ID. Then what else does it expect? It expects the sender is Alice, recipient amount. So we're going to say Alice as the sender, Bob as the recipient, amount as transfer amount. Remember, we created a constant with transfer amount, right? And also we now pass the expected deadline, right? Now what we've done is we've arranged, right? We've act, then we want to actually, we've arranged. Now what we want to do is, we've arranged. What we have to do is we now have to act. So to act, we have to prank like that. We are Alice, right? So we're going to do vm.prank, then do Alice, right? Then we're going to now call the create transfer. So I'm just going to copy this because of time. They're like so, and paste it. Just believe it. So SecretPay or create transfer is a payable function, right? This create transfer is a payable function. It takes in Bob, password, and duration. So let's run this and see if it does work. So expected hash. Okay, expected hash. So this expected hash. So it says expected but go identifier. So I think, okay, just here it should be comma. There should be a comma here, like so, right? Let's run it again and see if it works. So expected. So just before our emit, we did not pass a semicolon yet. So like so. Then just before transfer created, it says expected but got emit. Emit created, transfer created. What is wrong? So it says expected, comma, but got emit. So I think I ran before it saved. Yep. So SecretPay, this too. I know you'll be looking at, is this guy not passing semicolons? So our test does pass. So we're actually doing everything well, right? So right here, we did what? We arranged, we acted, then we asserted, right? So in fact, we did not do any assert. What we just did was that we arranged and we act. So what we actually did here was that in the emit event, we're expecting an event to be emitted, right? So we just did emit transfer created. That is it. It's quite simple. So we did not assert. There's actually no assertion here because it's an event. We're expecting an event to be emitted. We just arranged and we actually acted, right? So we did not assert, right? So we just arranged and we acted. So what is the next thing that we have to do? We can actually proceed to actually expect a failure. So yes, as in our test, there are situations whereby we want to expect a failure, right? We want to expect a failure. So let's say somebody comes here and calls the create transfer function with without passing an ETH. We want it to fail, right? So we want to also undo sad failures. So we can now create a function and say function. So there are quite a number of tests that we're going to start with test. Then we're going to say create transfer fail. Create transfer fails with 0 amount. Let's call that with 0 amount. So it's also going to be public. Now remember that this setup function always runs before the setup function always runs before the test function. Please remember that. So we also have to arrange, right? We want to act and assert. So what we're doing here, I want you to think about it. How do you think the flow of the logic would be? What we just want to do now is that we want to create a transfer that would fail with 0 amount. So we want to revert with an error. We're expecting to revert with an error, because what we will be actually doing in here is that we want to try to create a transfer function with 0 amount. So we would not be using 0, and we're expecting that what the transfer should fail. So we can at first prank that we are Alice, right? We can at first prank that we are Alice, right? So we're going to prank that we are Alice. Then we're going to also revert with an error, right? So I'm going to do SecretPay, right, dot create transfer, like so. Then also, because it's a payable function, I'm going to say value, right? Then I'm going to pass in not this transfer amount at the top here. I'm going to use 0. I'm not going to use transfer amount. Where is it? I'm not going to use transfer amount. I'm going to use 0 in this situation. Now, when I use 0, what are you expecting? We're expecting a failure, revert, like there should be a revert, right? So I'm going to just copy all of this here, ball, password, and duration. Ball, password, and duration, right? Then I'm going to now expect a failure, right? So I'm going to do vm.expect revert, right? Then I'm going to do, I can just pass in a text, amount must be greater than 0. Then also a semicolon, right? So I'm expecting a failure here because we're actually triggering create transfer with 0. So let's see what we have. So we're saying, remember, create transfer not found or visible. So my function name, create a transfer, it should be create transfer. So let's see. So we had this error. You must also learn how to read it. It's saying, remember, create a transfer is not found or visible argument lookup in contract table. So it's telling us that when I use create a transfer, it checked through SecretPay and did not find a function with that name, right? So that was why I knew that was the bug. The bug was definitely in my spelling. So I'm just going to fix that and let's try it again. So we see that, what are we saying? We see that two of our test paths, which is the test create transfer function and test create transfer emit event, but we see that this fails. The test create transfer fails with 0 amount. And why is that? So what we can do is, we are just going to read, it says failing test, encountered one failing test in SecretPay test or so, you must send ETH, blah, blah, blah. Now we're expecting a revert. It's telling us that you must send ETH. So now if you remember, in here, this is the reversion error. You must send ETH. So that is what it is saying, you must send ETH. So we wanted it to fail and it failed, but it was telling us that this test did not pass. And what can we be doing? What might we be doing wrong? So if we want to log more things, remember I said we can be more variables, right? If I do -vvv, I'm expecting it to log it with more details. So you see that it logs it with more details now. You can see quite a number of things. So it tells us that when we call the transfer, it tells us that when we pranked with Alice, it worked well. The create transfer to went through, right? This function went through the create transfer. It says create transfer, but it stopped, right? Then it stopped here. So this is the story changes, blah, blah, blah. It just logged quite a number of this, but it tells us that this function fails. So what might we be doing wrong? Let's think about, let's put our debug in. We pranked that we are Alice, right? Then we call the create transfer with 0, but we're expecting it to revert. Okay, let's move this just above here like so. So, and let's run this like so. Invalid token. Okay, I'm just going to remove this, then run it again. So we still have the same thing. Expected error. Now, I've seen this, what we did now is actually very correct. So the error we're passing in here, you see that it is, when you're writing tests, we must be very careful. Now, in our error here, we're reverting it, you must send ETH, here like so. Then in our secretpay.t.show, we're saying amount must be greater than 0, which is wrong. We want to revert exactly with the same thing. So yeah, it's telling us that error, this is not equal to, right? It's saying that you must send ETH is not the same thing as amount must be greater than 0. So this should work now. So let's try it. So I'm going to hit save again. Then I'm going to log this. So you see that all our contract passes. Now you might be thinking, why this was here? Why were we getting an error? Right? The create transfer would go before we revert with an error, right? So what this is doing is that our virtual machine here in Foundry is expecting the error. Like when you use the VM.expect revert, make sure that the error that you have here matches what you define in your contract. Then also, we're saying that the next thing should be a reversion, that is an error. Not that you're going to pass it after the function is called. This is a wrong approach. So we're expecting a revert first, then we're now triggering the revert. So we see that this works very well. So I'm just going to remove the verbose, then all our test passes, right? So we're making progress, right? And also here, you see that the same thing is used. You do not want to pass the expect emit after the emit. It will always be before, right? It has to be before. So we're making progress with our test. Now, what else can we do? We have to write quite a number of tests, right? We can also write a test that actually reverts when a user tries to actually transfer with an address that does not exist. Now, I know that we've not talked about this, or when a user tries to transfer with an invalid address, right? So in Solidity, we have a 0 address. So let's ask AI here and say, what is a 0 address? I'm going to hit Claude. Why is it not coming up? Claude. I'm going to, okay, let's ChatGPT not slimy. Nothing is happening. Okay, I'm just going to click ChatGPT here. And I'm going to ask it, what is a 0 address? And why I don't want to use ChatGPT because it's a little bit slow. Okay, so I'm just going to explain what a 0 address is. A 0 address is an invalid address. So let's say somebody is trying to create a transfer with an invalid address. We want to actually be able to catch that, like every possible thing, right? So also, I forgot to mention, if you want to see all of Forge's command, I think you can just do Forge. It's going to list all the commands of Forge that we can use. So you can see that we have Forge bind, Forge catch. So what this does is, if you run Forge catch, it removes the build artifacts and catch directories. Then Forge clone, Forge compiler, and quite a number of things. So it's very useful. You can just write it Forge and press enter. You see that Forge test runs the project test and all of that. So I just want you to know that. So now let's try to create a transfer with an invalid address. Let's say somebody wants to send, like Alice wants to send funds to somebody, but that person, the address is invalid. We want it to fail. We want to see if it fails, right? So we're going to create a function. I'm just going to copy this here like so. Then say function. Let's create transfer with, should we call it invalid address, or let's say with 0 address, right? So it's going to be public. So you should already be thinking how we're going to work at this. So what do we have to do? right? We simply have to prank, right? Then actually expect a revert, then trigger the create transfer. So I'm just going to copy this vm.alice like so, then also expect a revert because we're expecting a failure, right? Then I want to say invalid recipient address, invalid recipient address, right? Then also I now want to initialize a SecretPay create transfer function with a 0 address, right? So we're just testing to see all possible scenarios. Now I can now do the value would be transfer amount. I want to use the actual value, transfer amount. Then we can now do, we don't want to use Bob, we want to leave password and duration, but we want to use a 0 address. And to use a 0 address, we can just do address. To use a 0 address, then you're passing 0 like so. So we're expecting a failure. So if you do like so, not forge, just going to hit clear, then do forge test. So our test fails. It says did not revert as expected. So why this is not working is because we did not undo this in our contract, right? We did not undo this scenario in our contract. So I think that is why it is not working. So let's add, our contract does not have anything that undoes invalid recipient address. So let's go back to SecretPay.so and let's say require in our validation, right? We say if, we can say if recipient is, how do we tweak this? Right? If recipient is equal to an address, I'm thinking about how we'll do this. Then we can now see if the recipient is not an address, we can revert with an error, right? And that error will be invalid recipient address. So let's see if this would work. So we can say, let's do if recipient is not a 0 address, right? It should be successful. But if it is a 0 address, we want to revert with invalid recipient address. So let's run this and see. So we're having require bytes. Oh, I did not use a semicolon. I need to fix that. So let's see if that would work. Recipient. So I'm passing recipient here like so. I should use recipient, right? Not recipient. This is what we're passing. Then let's run it again here like so. So our test now works. So you see that once you understand the core basics, you will know how to. So why we're having that error initially was because we did not handle any scenario of invalid recipient address. So you would see that if I come to my SecretPay.so and I put in just a full stop and I try to run another test, it's going to fail. What you pass in as the expected reversion error must always match, right? So this is not the same thing as this route, the one with full stop, right? So I'm just going to change it and hit forge test. So now you're becoming a professional, right? So we can handle many more scenarios. Like we can handle scenarios around 0 duration. We can handle test around maybe multiple transfers and quite a number of things. So this is a basic way to actually this is a basic introduction on how to write tests, and it's very, very pertinent and germane as blockchain developers that you actually understand how to write tests before you actually deploy to the real world, because there are scenarios whereby malicious attackers would want to actually take advantage of your lapses as a developer. And people always follow where the money goes. So imagine you're working with companies like Uniswap, Aave, Polygon, and you're not able to write test suits properly. It means that your contract is actually susceptible to attacks, right? So I'm just going to write forge again. Then we should also be able to run coverage, right? So I'm just going to run forge coverage. I want you to see what that does. So if I say forge coverage, like so. Now, I don't know why why this icon is not coming up, but I wish it did. Coverage. Let's see if this is still loading. That's really bad. So what a coverage does is that a coverage allows us, if you check what this signifies, it tells us that the coverage helps us to generate coverage reports. So I just want you to see that. Now, in the deploy, so in the script.deploy, so you see that we have this, and this. Now, what I want you to pay attention to is the SecretPay. So what we have in our SRC folder, our contract here, we see that we have this amount of lines, this amount of statement and branches. Then we have functions. Now, when you check this, you see that the function has 50%, that is 2/4, the branches, blah blah blah, and the statement. Now it means that our test has just covered 2/4 of the entire functions that we have, right? So the coverage, so far so good. Our test has just covered 2/4 of the function, then 6/26 of the branches. The statements are just declaration, and the lines of code. So our test has not been well detailed. So we can proceed to actually write test as touching claim transfer and all of that, right? So the more tests you have, the more secure your contract is. And this is very, very important. And I thought that it is important that I would not do this tutorial and not mention about it. So if you head to the GitHub repository, I would have updated the test entirely to be more detailed, where you would undo the claim transfer test and also the refund transfer. So I hope that you've gained a lot in this tutorial and you're now proud to become a blockchain developer. Goodbye.